All right. There you go, Barry. Welcome, everybody.
Great, thank you. Welcome everybody to our forum on the future of reusable fabric face masks. My name is Barry Watkins, and I'm going to be hosting our group of panelists today. And wanted to thank everybody for joining us here. Just to give you a general overview of how we're going to be going today, we're going to be starting with a quick introduction, and then Dr. Songer is going to go ahead and give us an overall summary, and then we're going to move into the panel discussions. Our first discussion will take place around 12:45 Eastern. Then we're going to move into Q&A and take a little break after that, come back and do another PowerPoint presentation, another panel discussion, and another set of QAs. So if anybody has any questions or answers, please, QAs that they want to, questions that they want to get added here, please feel free to add your questions to the question and answer button at the bottom, and the team will get that set up so that we can go ahead and get those questions to the panelists when they come. So those of you who are not necessarily familiar with Helpful Engineering was created over a year ago, back at the beginning of March of 2020, when the pandemic began raging through the globe. And COVID began spreading worldwide, and a group of people decided to try to get together and help people utilizing a large volunteer organization and building off open source design with the idea of global design and local manufacturing. One of the things that was extremely important in the very beginning was a way to compensate for the supply chain in mask creation and a number of other different areas. And so with that, we at Helpful had started working with Dr. Songer and the Maker Mask Project in order to create local mask creation ability anywhere in the world. So Dr. Songer is a biomedical engineer, a researcher, and a scientist. She received her BS and master's in biomedical engineering with a focus on electrical engineering and medical devices. She's always been fascinated by how the brain can interface with electronics. And she got a PhD in health science and technology at MIT and at Harvard. Unfortunately, during her postdoc in a junior faculty position, she developed occupational asthma. And she was literally allergic to her job and all of the fuzzy, furry creatures in the research facility. And that started to, have her begin looking at the, at how she could solve this through masks and such. And at the beginning of March, around March 11th, she joined us here at Helpful with her project. She finished a literature review, a preliminary safety analysis, and tested a number of prototypes, and was busy making masks for her family. But she wanted to make sure that it wasn't just her family that benefited, but she came up with a solution that could help more people. And in conjunction with us at Helpful, we created something bigger. And Dr. Songer will tell you about the work that she did, and shared the ideas, the designs, and the research that she'd done with on the mask with a bigger audience. And now we're going to share some of that mask information and design with you. And Dr. Songer, I want to welcome you to the discussion today.
All right, thank you, Barry. That's a whirlwind tour to some of my background. Today, I'm going to be talking about masks for COVID-19 and beyond. And as Barry mentioned, it's a subject that's near and dear to my heart and has been for a long time. Since I developed occupational asthma, I started having masks with me 24/7 everywhere I went for occupational reasons, and then to help deal with dust and smoke and all sorts of other things. So coming into the pandemic, I had a lot of experience with masks. And as he said, I worked on doing even more research in the area and helping share that. And that's how we founded Maker Mask, to share both mask science and designs. And today I'm sort of going to give a whirlwind tour of some background information, and then really focus on a lot of the standards and testing, and talking about how that applies for both the DIY sewist maker and makers, as well as the larger mask making industries. And there's always something that is a little challenging, and the way my screen is advancing my slide is that thing today. All right, so here's just a quick view and a reminder that you use different masks for different tasks. And so before COVID, I'd used a lot of different masks, starting, I think the earliest is my Sunshine Bear Halloween costume in 1983. And as we entered the pandemic, it became clear that not all of these masks would be useful for COVID, for helping prevent the transmission of the disease and to help protect the wearers. And for each of these masks, there are pros and cons, but none of them were quite right for what we needed. And as Barry mentioned, there were a lot of shortages as well for both medical masks and personal masks. So by now, everybody's tired of figures like this, but it's important to talk about how COVID is transmitted, both in terms of respiratory droplets, which in the early part of the pandemic were the focus, and those tend to be the larger droplets, as well as aerosols, which become more and more important if you are in enclosed spaces in poorly ventilated areas. So the goal of the masks for COVID are to help protect the mask users from the droplets of others and to help contain the users' droplets to themselves. So that means that you need protection and a barrier essentially going both ways. And in order to accomplish that, for COVID, all of the masks need to sort of incorporate these three essential design parameters, including the fit of the mask, because if it doesn't fit well, everything leaks out the edges. And then the balance of filtration and breathability. So you're trying to have breathability be good for comfort levels, and the more filtration you can get for given breathability, the better protection you're going to get. So when you're talking about fit, the biggest issue there is the design of the mask. And so there are all sorts of different designs that work for different people and take into account different face shapes. And in the sort of DIY and maker community, we've seen a massive evolution over the course of the last year in getting more and more fitted and more comfortable masks to users. And we're excited about seeing how that translates into the variety of options available on the manufacturing side. And this slide is a little busy, but essential design parameters: the mask needs to cover the mouth and nose fully. It needs to fit snugly along all the edges. A lot of people have discovered in this past year that having a flexible nose wire or nose bridge is pretty essential for getting a good fit. And for people with glasses, we've known that right along. Another component is having a large enough surface area, so enough fabric area that you can easily breathe through it. So that reduces the breathing resistance and reduces the amount that leaks out the sides. And then how the mask is attached to the head and how you secure it there matters an awful lot. And that sort of combines with the fitting and also how people wear them. So donning and doffing and whether they wear them appropriately. Because we've all watched now countless hours of people with masks held on below their noses. And we're sitting there going face palm, you're not completely covering the mouth and nose, so the mask isn't going to be effective for what you're using it for. And then in both the DIY settings and the manufacturing settings, having multiple sizes so that you can accommodate different face shapes and sizes makes a big difference too. And so the picture on the left here is of the Maker Mask origami, which is one of the Maker Mask designs. But Sophie Passmore will be talking a bit about her designs in the panel, and we know we've got representatives from Vogmask and some of the other folks as well. And so the specific design doesn't matter as much as ensuring that you have a good fit and that it stays in place for the amount of time that you're using it for and for the activities. So when we talk about filtration and breathability, that depends a lot on the different fabrics used and how many layers of fabric are used. And so early in the pandemic, people loved to include vacuum bags in the middle of their masks, which have great filtration, but they're not breathable. They're not designed for people to be able to breathe through them. So getting that balance is crucial and has been throughout the pandemic. For a lot of the fabric masks, the WHO standards and a lot of the other standards across the world have been migrating towards suggesting at least 3 layers to get the kind of filtration you need, and then a balance of different mask materials depending on what you want the function of those layers to be. And as you look in sort of transition from the DIY world into the manufacturing world, you start to see a greater sophistication in those layers. In general, the mask fabrics are either wovens, knits, or non-wovens. And prior to the pandemic, most people were familiar with wovens, which is sort of your standard sheet material, and knits, which is your standard t-shirt materials. But the world of non-wovens was less familiar to people outside of the mask industry and filtration industries. And that's because it's not as commonly used in clothing. But when you get into mask manufacturing, you'll find when you look at the breakdown of layers of materials that they're using in their masks, they almost always include non-woven layers. And that's because non-wovens tend to provide a good balance of both filtration and breathability. And they're especially known for filtration. And I could give a whole talk on non-wovens, and I will try to prevent myself from doing that here. But as we go through the discussions today of the different mask materials and mask types, both in home settings and manufacturing settings, you'll hear different types of non-wovens discussed. And those typically break down into spun-bond non-wovens, which a lot of us are using in our sort of DIY sewing and mask making efforts. And then the melt-blown and electrospun non-wovens, which you hear about more commonly in sort of mass manufactured masks. And since it is a topic that people are generally less familiar with, just wanted to show this table to give a quick idea of the trade-offs you get between those 2 classes of non-wovens. So the spun-bond non-wovens, which we focused on for our DIY and sort of home mask making efforts, have a lower filtration than the melt-blown and electrospun non-wovens in general. But they have a higher fabric strength and durability, and they're more robust to washing. So it makes it easier if you're going to drop them into the washing machine or even hand wash them. They last longer in general in those situations. And for people who don't have manufacturing controls in place, there's less inhalation risk associated with working with them. And so that's one of the reasons why the spun bonds have cropped up as a DIY favorite. On the other hand, the melt blown and electrospun non-wovens have a higher filtration capacity. Usually they have a much greater surface area, but there's more of an inhalation risk associated with working with those materials to construct masks. Once they're in the masks in the appropriate ways, then that's really not so much of a concern, but it's important to have appropriate manufacturing controls in place when looking at that. And they tend to be less durable, they're easier to tear and less washable than the spun bonds. And once again, in manufacturing settings, there are a whole bunch of things that they can do to sort of adjust for and calibrate for that, but those materials aren't as commonly available in the DIY settings. But that is my whirlwind tour of non-wovens using masks. For the DIY efforts, and I'll talk about the spun bond non-wovens a little bit more, they ended up being a good choice because they're reusable, they're washable, and they're more readily available to consumers. And this is just sort of my geeking out slide on how spun bond non-wovens are constructed and how you can identify them. So I don't really need to go into that, but it's that fibrous web that helps with the filtration and is similar across all of the non-wovens. And then finally, for reusable masks, the washing instructions are really, really important. And we'll see that crop up in the standards as well, that if people are going to be reusing masks, then being able to clean them or disinfect them appropriately makes a big difference. And I know we're going to talk about some of that during the panel discussions later, but whenever you're looking at getting or using a reusable mask, it's important to check and see what the washing instructions are, especially because you do tend to need to handle them a little bit more gently as you go to the higher filtration materials. All right, so that was my whirlwind background. And now I want to talk about masks that are used for COVID and sort of avoid all the ski masks and the Halloween masks and focus on the 3 categories of masks that we have standards for. And one of the important things with the standards is that it then allows you to test the performance of your mask materials and designs to see that they're actually providing the function that you expect them to. And so the 3 major categories are the barrier face coverings, which is what the ASTM F3502 standard covers. And that's new since the pandemic began. And then there are medical masks, which are covered by ASTM F2100 standards, or the European standard is the EN 14683. And then N95 medical respirators. And for the US, the standards for that are the 42 CFR Part 84. And in European markets, that is EN 149. So as people are talking about masks, these standards are very different, and the intended use of the masks and what you expect for them is different as well. So even within masks for COVID, you have different masks for different tasks. And I'll just run through sort of the technical differences between these before I go in and focus a little more on the ASTM F3502. So the barrier face coverings are really intended for use as source control. So they contain the user's droplets, and they also provide some amount of filtration for inhaled materials, and they're actually testing the standards for that as well. Medical masks are a bit different than that. They're also designed to provide source control, but they also are fluid resistant so that they act as a barrier to water-based droplets as well as surgical situation type blood sprays and spatters. And that's pretty different, but they don't fit as tightly to the face, so they're not intended to give you good protection from the smaller inhaled particulates. And then sort of the gold standard for protection from inhalation of small particles are the N95 medical respirators. And those are really designed to filter out the small particle aerosols. With those, in the context of COVID, you just want to make sure you're looking at N95s that don't contain exhalation valves, because if there's an exhalation valve, they don't provide source control. And so that's just a key thing to remember, because prior to the pandemic, a lot of the N95s sold outside of medical settings included exhalation valves. So this is just sort of, once again, keeping with that comparison. The barrier face coverings are really snug fitting, and they are designed to reduce leaks of air around the edges. And the standards for that include the possibility of quantitative fit testing, which is optional, but they do require that there are design elements to reduce any sort of leak exhalation around the mask. Whereas medical masks are loose fitting and have the most leak. And if you use them very much, you know that they have a tendency to gap, especially around the cheeks. And then the N95 medical respirators are tight fitting and have the least leak. Fit testing is required. And when they are properly worn, they have very minimal leak around the edges. In terms of filtration, the best are the N95s. So they actually provide 95% filtration of the 0.3 micron particles. The barrier face coverings are required for the ASTM standard to filter out at least 20% of airborne particles. And when we go into that, we'll dive into some of those details later. And then the medical masks don't provide that same level of filtration, largely because of the leak, but they're tested to different standards. They don't actually test them against a 0.3 micron particle size. And so that's why that's an NA here. And then finally, the barrier face covering standard is the only one that has specific criteria for reuse. So both medical masks and standard N95s are considered disposable. And so one of the real things that we gained with the barrier face covering standard is some idea of what performance criteria you need to meet after you wash the mask. So this slide gets into the nitty-gritty of what all the testing and performance standards for all of the masks are. And the real point of this slide is that it's confusing. And if you want to go through it in all the details, then that's going to have to, like, there's a link to the blog and you can go to Maker Mask and sort through it. But it meant at the beginning of the pandemic, it was really challenging for users and makers alike to decipher and understand what people were talking about when they were talking about filtration and breathability. And most of those testing standards are challenging to find and navigate, and it's challenging for new users to test their masks according to those standards. So now I want to talk a little bit more specifically about the ASTM F3502 standard, because that's the one that's most relevant for the reusable masks. And we'll talk a whole bunch about the pros and cons and different components, and then how that applies for manufacturing as well as homemakers and users. First, just the quick definition. To be an ASTM F35 compliant barrier face covering, it has to fit snugly to the face, all those things. It's used primarily for source control, so it's not a medical mask or a respirator and isn't tested to those standards. And they can be either disposable or reusable. And when we talk about them, we're mostly talking about the application of the standards to the reusable masks. But keep in mind, if you're searching for masks that are F3502 compliant, you'll also run into a whole bunch of disposable masks. So that's a thing to keep an eye out for. When evaluating masks to this standard, there are 3 performance areas. The first is protection for both yourself and others, and that's assessed by design analysis and leakage assessment of the fit, which we talked about a little bit before, and then the filtration specifically at 0.3 microns. And when you're looking at filtration data, the particle size matters. And so that's just another thing to keep in the back of your mind. In terms of comfort, that's assessed with breathability and airflow resistance. We'll talk about that a little bit more later. And then for reusability, all those 3 criteria for fit, filtration, and breathability have to be assessed again, both before and after the maximum number of washings. And then based on that, the mask can be classified both in terms of filtration and breathability as either level 1, which is sort of the minimum performance criteria. So it has to filter out at least 20% of the 0.3 micron particles, and breathability. And for the level 2, which is the higher performance standard, it has to meet at least 50% filtration of the 0.3 micron particles, and it has a much lower breathing resistance, which means that it's essentially 3 times more breathable. And so the level 2 mask will be more comfortable. And then just to keep it a little extra confusing, they classify level 1 and level 2 separately for filtration and breathability. So you can have a mask that's level 1 filtration and level 2 breathability, or level 2 filtration and level 1 breathability. So you can get anything from within that mix. So one of the advantages of this F3502 standard is that it tests filtration and breathability using metrics that are similar to those used for respirators. And so I've tried to highlight the commonalities here. For the ASTM F3502 standard, they're looking at 0.3 micron particles and a similar setup to what they're using for respirators in the US, as well as respirators according to the European standards. So that helps you sort of see on a scale of performance how a given mask tested to the standard is doing. And you can keep in mind that level 2 performance is at least 50% particle filtration. So you could have a mask with 95% filtration that was tested to this standard. Most of the time, that kind of mask is going to be a mass manufactured mask. And then for inhalation resistance, once again, the same type of standard and type of measurement is used for both the ASTM F3502 as well as the respirators for both the US and European standards. And I'll just zoom in quickly on those so that you can get a sense of how things fall in the spectrum of performance for filtration at 0.3 microns. So the level 1 standard is a minimum of 20% filtration, and then level 2 bumps up to 50. And then when you start looking into the respirator standards, that's where we're seeing the 94 and 95% standards. So in general, in terms of filtration, the respirators are going to perform better. So you might ask why you would want a barrier face covering instead of a respirator, if that's the case. And one of those reasons is when you switch over to breathability. So here the scale is flipped essentially, where the breathability requirements for the barrier face coverings are much lower, and lower is better. So a respirator can be 7 times more challenging to breathe through than a level 2 barrier face covering. And so that has a lot of implications in terms of comfort and how long you can wear a mask comfortably as well. All right. The disadvantage to the ASTM F3502 standard, especially for the small manufacturers and makers, is that it's a fair amount of work and a fair amount of cost to test just for the filtration and breathability that I was talking about before. So for a reusable mask, for the standard, you have to test 10 masks, new, 10 masks after the washing instructions, whatever they may be, for a total of 20 masks, and that costs $4,000 to $5,000 per mask that you test. Sorry, per type of mask that you test. So that can add up quickly if you're trying to sort of learn about what the best combinations are, especially, and to get that ASTM F3502 compliance. The good news about having a standard, if you are not looking to show full compliance, but just to get a general idea, is that you can test materials and masks in smaller numbers to see if they are tracking and trending in the right direction. And so that's what we did with MakerMask. We tested a number of mask fabrics and the MakerMask origami design to see how they performed relative to the requirements of the standard. First, as I mentioned before, the mask fabrics you choose make a big difference. We tested 2 different mask fabric combinations. One was 3 layers of non-woven polypropylene, and I have all the details that you could possibly want on the non-woven polypropylene we selected and how we chose it, but not enough time to talk about it in this talk. And then a combination of cotton, non-woven polypropylene, and cotton, which is much more common in the sewing and making communities, and in fact is the recommended combination for the Canadian mask standards. We tested both mask fabrics as well as mask prototypes, and there are pros and cons to that. One of the nice things about testing fabrics is that then you can get an idea of performance independent of the design. Whereas when you're testing the mask prototypes, then the performance of the design and the materials is all bound up in one. So first, here are the results that we got for the breathing resistance and 0.3 micron particle filtration for the two combinations. So both of them fell well below the level 1 requirement of less than 15 millimeters of water. However, the non-woven polypropylene, which is that non-woven material, was much easier to breathe through. And so you can see that here in the green bar. And it satisfied the level 2 requirement for breathability as well. Whereas the cotton non-woven polypropylene combination would still be considered very breathable, but it satisfied just the level 1 and not the level 2 criteria. Then for the 0.3 micron particle filtration, both sets of materials actually performed pretty similarly, and both of them satisfied, on average, satisfied the ASTM level 2 requirement of greater than 50% filtration. There are a couple of caveats and side notes there about, for the standard, how that's calculated. But you can see that in both cases, the standard deviation dropped slightly below that line. So the claim of the level 1 is a safer claim in terms of you absolutely have satisfied that with all of the masks tested. But regardless, in both cases, both combinations, the non-woven polypropylene with 3 layers and the cotton non-woven polypropylene cotton combinations are consistent with the requirements for the ASTM F3502 standard, which means that they perform well relative to other masks that are also meeting that standard. And I can answer questions about that at the end. I know that this is all very compressed in terms of information.
We have a number of good questions waiting for you. Don't worry, Doctor.
I know, I've got 2 minutes, right? In addition to the F3502 standard, we also test the same fabric combinations to the medical mask standard. So that's the ASTM F2100 standard. And this is useful because it also shows breathability performance with similar trends. So the non-woven polypropylene combination easily satisfies the breathability requirements for the medical mask standards. One of the things that medical masks require that the barrier face coverings do not require is a fluid resistance. So being a barrier to the sort of larger droplets. And the non-woven polypropylene satisfied that requirement, whereas the cotton combinations didn't. So there are some applications, depending on your task, where you might prefer the non-woven polypropylene components for that reason as well. And then if I really want people to ask questions, I can talk about the medical mask filtration efficiency standard, which tests to a different size particle. So it is not directly comparable to the F3502. And in this case, we also see sort of similar performance between the two materials in terms of filtration. All right, so just the quick summary is that both of the combinations we tested would pass the ASTM, are consistent with the requirements for the ASTM F3502 standard. Like many makers and SOAS, we weren't able to test 20 masks. We were only able to test 3 masks of each type for that standard, just for budget reasons. But it gives us some confidence in terms of what the performance would be at a larger scale. And then it has a summary of the medical mask performance as well. All right, and then just a final thank you to everybody that made masks in this last year, whether it was larger manufacturing operations scaling up to meet the needs and in the global shortages that we all had, or the millions of people that sort of banded together to get masks out to the people and their communities and around the world that needed masks during this crazy last year. So thank you to all the mask makers out there. And then a quick thank you to the Maker Mask team. It was really impressive to see the number of volunteers turn out to help us put together all our mask designs. We published a whole bunch of research on the blog, and I encourage people who aren't already familiar with us to check that out. And it was just an awful lot that got accomplished in this year by people who took the time out of their lives and schedules to help make a difference. All right, Barry, now I'm ready to turn things over to you for questions.
Excellent. So thank you so much, Dr. Songer. And I want to thank the Maker Mask team as well. It's been an amazing year working with everybody, and there's been a lot of great progress. There have been a lot of great questions as well, so we'll go ahead and get right to them. Devin had asked, now that supply shortages have loosened in most Western contexts, and we know more about the effectiveness of fabric masks, what are the ethical considerations and guidelines around advocating for reusable respiratory protection? What kind of information should people be include with promoting, selling, or gifting home built masks? Those are two questions that came from Devin.
Yeah, that's an awful lot of questions sort of wrapped up into a relatively small package. So I think one of the things to keep in mind is that our understanding of the needs for reusable masks in the context of infection control are growing and evolving and are going to continue to evolve in the next few years, more than that, hopefully. So having those caveats and the understanding that you do want different masks depending on the risk level and situations that you're in. If you are in an operating room with patients that are coughing all over you, then you need a different mask than if you want to go for a walk out in a community of unknowns, right, with unknown vaccination status. So I think that's important. In terms of reusability, one of the major challenges I see is in terms of cleaning and disinfection. So if you're going to have a mask and you're going to put it up in front of your face, and if it's actually functioning to trap germs and other guck that you don't want to breathe in, then you do want to make sure that you are washing it regularly and correctly. And the standards for how to approach that are still evolving, especially as you look at different risk categories. So clear washing and cleaning instructions, I think, are critical, as well as donning and doffing how you wear and handle the mask. And just keeping in mind that a lot of these considerations are different in the context of infection control than for, say, smoke inhalation and pollution. And so although there's overlap in what you're looking for, there are a lot of differences as well.
And Haridas had asked about the issue, kind of like the issue related to microplastics being released from nonwovens during washing.
So that is a huge, huge question. And it's something that the ASTM committees are looking at in general in terms of microplastics in washing. And sort of there's been a whole parallel field of literature in the background talking about microplastics in general and for masks and for washing. I think that, as is the case with so many things, which materials you choose within a subset make a big difference. For the spunbond nonwoven polypropylenes, they have larger fibers and higher durability, and so are not likely to be releasing fewer microplastics relative to some of the finer melt blown and electrospun materials. But that is definitely an evolving question and issue. And the research I've seen so far suggests that masks are not one of the largest problematic players in that field and industry right now. If people want more information on that, I've got a whole bunch of literature stacked away, and like we can get a dialogue in some of the other chats and forums about that. I think we have some of it posted on the website as well. But in terms of reusable masks, one of the things we're hoping for is to reduce the total amount of waste. And we've seen a lot of crazy waste with the disposable masks in the oceans and in our forests and everywhere else in this last year. So looking forward, finding better solutions to reusable masks, I think will benefit all of us in terms of both our personal health, global health, and environmental health.
Excellent. I had a question actually. What are the difficulty levels with the various types of non-woven manufacturing techniques? I know that some are very difficult, so what is the general, I don't want to get too in the weeds, but kind of what is the general difficulty level in the different types of make, and how, I guess that would also affect availability of that type?
Yeah, so that affects price, availability, and time, all sorts of things. The spun bond non-woven polypropylene is generally a bit easier and less specialized. As we've found partly with the shortages, right? As you deal with smaller and smaller fibers, you generally get more and more finicky processes in a lot of ways, especially if you're looking to get good, even fiber distribution. So this is sort of heading into the way into the weeds. But one of the issues when you're using nonwovens is that they're not all created equally. And as the fibers are sort of spun and dropped into their weaves, well, they're not weaves, sorry, into their fibrous mats, you need to actually have very well-regulated, controlled systems if you want all the sort of squares of the mat to have a relatively consistent fiber distribution. So that's one of the differences between medical grade materials and sort of landscape fabrics is that fiber distribution. And a lot of people that have worked with these materials, you hold them up to the light and you can see the light shining through brightly in one section and then another area with a very different density. So a lot of the technology changes have been in how to better control the distribution of fibers as you get down to smaller and smaller sizes. And a lot of the cool work, which we'll hear about probably in some of the manufacturers talk about masks, is in the electrospinning process for getting those ultra fine fibers distributed in the way that you want and with the charges that you want. And as an electrical engineering, I would love to spend another hour talking about that, but we should probably
move along to some other questions here while we've got a couple of minutes. Lynn had asked, how long is a well-made cloth mask covering safe to use? Is there a recommended number of washings or some other criteria when you as to when you should replace it?
Yes. So that's the easy answer. The F3502 standard helps provide information on that for their manufacturers, because if they are going to market it as reusable, they need to actually test the performance after whatever they think the maximum number of long range cycles is. So you have more assurance that the mask is still effective and functioning the way you expect it to be after the number of washes specified. When you're using homemade masks, then that's a different question, and it depends on what materials you're using. And so all the materials that are used are going to degrade with time, and it's going to depend on what washing method you use. It significantly depends on that. So for the maker mask designs and material combinations, we haven't been able to fully test that. We have anecdotal evidence that they're good up to 50 or so washes, but we have to sort of tell users to use observational cues to tell when your masks are wearing out. So if things are starting to fray at the edges, around the seams, if you're seeing fibers shed off of it, regardless of what material the mask is, you should retire it.
It's time.
And most people are washing and not disinfecting the masks. So when you start to see the masks get dirty and they're not getting clean as you wash them, that might be another good sign that it's time to retire the masks.
Good.
But as I said, that we'll talk about that, I think, more in some of the panels as well. I know a lot of our speakers have joined the global forays and sort of looking at different washing and disinfecting techniques for masks.
So would you recommend double masking? In other words, like a well-fitting mask and a medical mask underneath, or any combination thereof?
So I think that falls into the different masks for different tasks category. And the answer is sometimes yes. I can tell you that when I went and got my first vaccine shot, in the sort of group arena situation, I double masked. And that was to increase the filtration level, essentially, of the mask. There's a post that goes into the details on that on makermask.org, but it depends on sort of the breathability of the mask that you're using. You want to make sure that the masks are comfortable and breathable for the total amount of time that you're going to wear them, and that you're not going to be shifting them around and breaking the seal. So you don't want to make matters worse by, layering layer upon layer upon layer of masks. You do hit a point of diminishing returns there.
Okay. And I've got one last question here before we wrap up on this one. And Edward had asked, understandably, a respirator mask like an N95 would give you better protection, but by limiting ASTM 3502 to level 2 at 50% for the NACL test, is that committing to the public perception that the designs that perform closer to respirators are still not good enough?
That question's a trap.
Damn you, Edward! Try to trap us!
So one of the big challenges has been, how do you define what is good enough? And there isn't a really great answer for that. So I think in part, yes, by choosing to set the standard to the most difficult to filter particle, it does make masks seem like they could be less effective than they actually are. And that gets into one of the really big rabbit holes of this pandemic, which has been the discussion of what particle size matters and how much protection you need to actually prevent disease transmission. And those questions, even though we've been diving into them rigorously for the last year and even before that, aren't fully resolved, and they're different. The answers are essentially different when you're talking about infection control and respiratory droplets than when you're talking about smoke. And this is a sort of complicated slide that gets into the complicated answer to some of that, which is in terms of respiratory diseases like COVID, which particle sizes are getting deposited into the lungs and how much of them are. And so the area above the curve is stuff that's exhaled, so we're not going to worry about that so much. You can see that the blue area of the curve, that those are the particle sizes that are sort of less than 0.1 microns in diameter. So particles that are smaller than the size of the COVID virus are not likely to be contributing to disease transmission. And so that huge area of very small particles is a little bit less concern for infection control than it is in a lot of industrial settings and settings where you have these really, really small particles. And so a lot of the particles that are of the largest concern are in this larger bin size. And we expect that masks perform better and better as you go to larger and larger particles, because the testing methods themselves are designed to see where the masks perform the worst. And I don't know if that helps sort of get at that, except to say that, yes, I think that the way the standard is set up, it makes it seem like the masks might be less effective than they are. But there's a lot of reason to think that, even though you are not filtering the smallest of the small, you're still doing pretty well in terms of reducing and minimizing your risk.
Okay, great. I'm going to put a hold on questions at this point. We have one or two other questions that may come up, and we may be able to get back onto them. I'm going to keep us moving forward here on time, and we had a small break built into the system, which of course we blew right through with questions. So good for all of us. Let's go ahead and move ourselves into our next section, which will be a PowerPoint presentation. And this is going to be with Wendover Brown. And let's see if we've got that available and ready. Are we good to go?
Barry, I'm going to stop you right there.
Please.
Hi, everybody. I'm Brianna. We're actually going to go right into the DIY panel.
Oh, great.
Yeah, so, and then Wendover will take over right after that. But yeah, Barry, if you don't mind giving some intros for the DIY panel. Yeah. And Rebecca.
And
then
sorry,
will,
guys, that's
moderate.
on me. I just actually skipped ahead an hour. Yeah, not a problem at all.
No, but thanks, Barry.
Yeah, so let's go ahead and move into our next discussion, which is a panel discussion that is going to be led by Dr. Songer. And Dr. Songer, I'll let you go ahead and introduce the members of the panel and take it from here.
I think Rebecca is actually going to introduce the panel and lead.
Thank you, Rebecca.
Yes, I'll take care of that.
Thank you, Rebecca.
I'll be the moderator for this DIY panel. So let me first start by introducing who we have here. You guys have already heard from Dr. Jocelyn Songer. She is the founder of Vogmask. And then we also have, the next person we have is Sophie Passmore. She's a founder of Mask Makers UK, which is an online community of sewists during the COVID-19 pandemic. We have Kim Leo, the owner of Taolu Creative, and the creator of Sewing Mask Pattern Facebook. And last but not least, her face is not being shown right now here because she's in Germany and she's unable to actually show up as a panelist. But she has contributed a lot to this panel through her discussions with us. You might have guessed who this is. It is Iris Lukos. She is the creator of the hybrid mask, also known as the Luckhouse mask. And if you're like me who does not speak German, you probably recognize her name better as Iris Luckhouse. I've interviewed her ahead of time, and I'll be sharing some of her responses during the discussion. This panel is 45 minutes long, and there will be a 15-minute Q&A that follows, so you can have your questions ready for that. We will be discussing a very wide range of topics related to DIY masks. And that's all I have to say right now. Without further ado, let's begin with the very first question for all the panelists. The first question I have for all three of you who's here is, tell us about your organization and your role. How were you involved during the pandemic, and what drove you to this mobilization? I would have Kim Leo. Would you like to start?
Sure. Hi, I'm Kim Leo. I started this. So I started a Facebook group because I couldn't get my PDF pattern to share with a fabric manufacturer warehouse that I know that had a hydraulic press to make cutouts. So that's one of the cutouts. And then the other one that I did, which I couldn't get it to share. So I created a Facebook group because I could join him with my Facebook group. And it started with 15 of us, and now we're well over 13,000. The group was created to share information on patterns, materials, best use, best fit, and information. In the group, there are no sales of masks allowed. That was my purview during this, because we're in a global pandemic. I didn't want this to turn into a price gouging issue, or it was purely, okay, let's pull together all these different people who are different backgrounds. I have no letters behind my name to give me a degree or any of that, but I've got enough knowledge to be dangerous in different ways, I guess. So the non-woven polypropylene. We ended up using a lot of this. And before this, I owned a laundry service. I ran a diaper service for 10 years. So my washing background is quite strong. And I contacted one of my former resources for bags because I used their laundry bags with our service for washing, for drying, and said, hey, do you have stuff that are just sitting there that are misprints? And they connected us up. I used to do a lot of hiking. I do a lot of different things. So I connected up with Night Eyes, Gear Ties, different people. And by having this group of 13,000 people, the amount of knowledge and across the spectrum information was fantastic. And like, that has been my huge, like, awesomeness of this is we're connecting these people who have this information to share with dying skills, which makes me sad because like the trade skills of sewing and the manufacturing of different things. So we've connected this way to connect all these people and share the information as fast as we can. And Jocelyn has been amazing for pulling through the research and pulling down all the itty bitty stuff of the nitty gritty that I toss ideas out and she goes, oh, this is how we do this. And that's what's been great about connecting with all of you guys is that we all look at it in a different way and go, oh, well, try this. Oh, try that. Like, so this template here is actually from Make It Labs in Nashua, New Hampshire, and they're close to me. So I sent him a Facebook message and said, hey, can I get permission from you to make your design into a cutout? My brain is not working right for the words. And make it so I can make many templates of it, cut them and just send them out for people who need to make. And he said yes. So I had it made in different sizes and I cut hundreds of thousands of pieces from donated materials from different people. I have local to me another 2 places that have N95 material. And this guy here is the outside of masks. It was given to me by a local place in Brentwood. They ordered it for a misprint 5 years ago, but I sent out rolls of it. And I think that was my biggest, I love being able to see all the people that came together during this. All of you came together in different parts of the world, different parts of the fields. I still thank you guys all for letting me be part of this group. I don't feel like I've got the credentials that go with it.
Well, thank you. You have done a lot for this. And now, since you're talking about all over the world, the next person I would like to speak is Sophie. Can you talk about your involvement?
Hi, greetings from Brighton, England. I'm Sophie here from Mask Makers UK. I started up this group because in early March, there wasn't one that I could see was existing on Facebook for the UK. And I was part of Mask Makers, the American Mask Makers group on Facebook, and was, I really felt the call to arms, so to speak, for making. As a maker, as an artist, as somebody who, is a freelance maker. So this felt, was like something I could really do when the rest of the world was we were in this novel coronavirus situation. We didn't know what we were dealing with, yet this became something that I could do. So I put out a call for help on the larger mask maker group in America. And a few people, namely an influencer and a sewing blogger named Portia Laurie, helped me to create Mask Makers UK, the Facebook group. So From there, we created a maker support, basically. So it's a resource pack, including, you know, mask patterns, disclaimers, care and laundering, trading standards eventually. So we just needed to have resources for our makers to help support them in the work that they were doing. And of course, that evolved over time. And then, of course, like the main part of what we were doing there was to be a learning community. And I think this is what I really connect with what Kim was saying about the connections that were made and the sense of safety that needed to be there in the group in order for people to learn and grow effectively. You know, the moderators had a full-time job keeping the trolls, the naysayers, anyone who was going to be negative. As soon as there was a whiff of it, it had to go because this was a safe space. And so we talk about as well, you know, of course, this dire need for masks. So the requests were urgent and they were coming to us in just numbers that we could barely cope with, because they would type into Facebook, you know, mask makers, they would find us. And at the beginning, we thought, okay, we can do this. And we had threads, we had a way of organizing it. But of course, Facebook is a totally you know, unacceptable place. It's not the kind of software you need to be using. It's not, you know, efficient for organizing this kind of task. So we had to instead completely stop all matchmaking requests, and we just focused on maker support. And so we became more of a hub, a community at that point. And, you know, I'll talk more about how our process went, but basically I'm coming from an arts background. It was about communication. It was about creating a community. And then through the help of some tech support from other wonderful COVID volunteers and the geeks and the nerds whom I owe so much to, we were able to build software that could help support a request and donation system. So that came later. But so that's where we are right now, and we're still ticking along, but of course it's slowed down significantly. And so I'm really curious to hear about how it's going everywhere else and what other people's experiences are.
Thank you, Sophie. And next up is Dr. Songer. We've heard from you already, but you come from an engineering perspective. So tell us about how you got involved in this and your organization.
Yeah, so I started my involvement coming from a medical device perspective, which was a different angle to be navigating things from. And my early focus was on stopgap mask solutions for healthcare providers, because in my area, the EMTs, first responders, and even the local pediatricians' offices didn't have any masks to work from. And as a former EMT, none of the masks that I had used for my asthma or other situations like that felt appropriate to the use. So for me in the early days, both filtration and water resistance were really important, because from a medical mask perspective, one of the things you want to do is have an actual barrier to fluids that prevents the droplets and spit and phlegm and whatever else from going from one side of the mask to the other. I used to tell people, it's like, I feel confident wearing my mask that if a dog licks my face, there's not going to be any dog spit in my mouth afterwards. You know? So coming at things from that perspective, and then sort of navigating all the regulatory requirements and lack thereof was an interesting and sort of special place. And that's evolved a lot now that the shortages for healthcare providers are resolving, and there are more and more manufactured, fully tested and verified masks for that community. We shifted our focus more and more to trying to bring masks into the general community that still satisfied the sort of minimum requirements that you'd like to see from the healthcare side, and sort of like figuring out that fusion and crossover has been an interesting bit. And then supporting groups like Sophie and Kim and Becky Blank, who also was doing a lot of work with trying to get masks distributed throughout the country, was huge. And that's all sorts of different levels of skills and knowledge had to come into play to not just get masks made, but then to get them from people who could make them to people who could use them. And we've seen a lot of shifts in that over the course of the last year. And as we look to the future, I think one of the things we're hoping to get out of this discussion today in sort of our ongoing work is figuring out how to do things better, how to prepare and store the knowledge and information that we've gained, and to get it from our sort of smaller, more insular communities communicated across like the gulf and divide between the DIY makers and the manufacturers and the policymakers, and figuring out how we can sort of package the information we have so that we can use it more effectively and efficiently and grow from it so that we can respond to whatever the future holds.
Thank you very much. The next topic I would like to talk about is about mask design. Because I think we've talked about through your presentation earlier, Dr. Songer, we know that it is very important that we have good fit, good filtration, and good breathability. So first, I want to talk about what are some key features for fit and comfort, and how does your design take that into account? What are some questions that have come up as you try to design this perfect mask? Sophie, would you like to answer that?
Sure. So when we talk about my mask, I'm not sure there, but what we have with regards to Mask Makers UK is a community mask that we arrived at. So we and also there are a number of different endpoints for the masks. So there's a mask market, that is a commercial market, and then there's a donation market, a donation stream. So when we were donating, we were trying to develop a mask that could be one size fits all, good fit, with a filter pocket for future proofing it, because we didn't know about filters yet. Like we were, as Dr. Songer presented earlier, there were the vacuum cleaner bags, the coffee filters, and all sorts of strange things that people were putting in. We wanted to leave that kind of open. So we were doing a 2-layer cotton mask as we were entering into summer as well. And then we needed also, criteria was that the fasteners needed to be replaceable and adjustable. So we did side channels on either side of a rectangular sort of surgical style mask. So this is what we arrived at as a shared kind of consensus about what we could all make really quickly and donate generally. But there wasn't like a top down, you've got to make it this way. It actually kind of beautifully evolved as this seems to make a lot of sense. Let's make this mask. And so it has this reverse nose fold as well, and which Iris's mask also features. It's a wonderful, wonderful kind of a hack to the rectangular surgical style or procedural mask. And it just folds over the nose so that you can put glasses on top of the fold. It just creates a little bit more of a seal. It improves fit. So fit, and then it has to be, it's comfortable. So we're aware that when masks are uncomfortable, people aren't wearing them properly, they're fidgeting with them. So this mask was called the reverse nose fold, and it was a hacked surgical style mask. And again, it was it was emphasis on fit and pocket and nose fold.
Yeah, actually, that will lead me to, I would like to present Iris Wukol's mask also, because it is actually very similar to the reverse nose pleat that you were talking about. So as you know, I interviewed Iris ahead of time. I want to share a little bit about her interesting background. I don't know if all of you know that. She is an illustrator and designer, but her background was actually in fashion design. And she has studied in the class of the very famous fashion designer Vivienne Westwood. Iris' focus is on adapting historical patterns into modern use. And that came in so handy during the pandemic, because she started out by surveying all the different mask patterns out there. And she was just frustrated that nothing fit on her face. So she decided that I know how to adapt patterns. I know how to pull the good things from each thing and pull it together. And that's exactly what she did. So this is one example of her mask. She also did the reverse nose pleat, like what Sophie has done. She has the pleated surgical style so that it gives room for moving. And when you wear it, it gives you also extra room to just protrusion, so you have mouth room. And she has added a side channel that is very, is not part of the fabric, but it's an extra thin layer of fabric so that it can scrunch up very easily. And because it can scrunch up so easily, when you put it on the face, it lies very flat on your face and it gives that shape. This whole thing together creates like a pulley system that fits perfectly on the face. Now, I don't understand fashion design, so I don't know if that works, but for her, she put all that thought into it, knowing that it will, if you give the good fit. One additional thing she did was that mine doesn't do that because my face is different from other people's face. I have a flatter nose. She has added a slanted design so that it fits most people's face structure better. So I thought that was very interesting that if you're wearing one of her masks, you can tell people that you have worn something from a famous fashion designer. And now I know that since we're kind of short in time, I'm going to move on to the next question. Washing masks is a very, very big topic. And I know Dr. Storm mentioned that. I would like to pick Kim Leo's brain because she is very familiar with anything cleaning related. Can you give us some insight on cleaning masks?
So you really want to wash and clean masks like you would treat anything that has chicken guts on it. That's the easiest way for me to explain it to most lay people is if you're thinking it's dirty, would you put chicken guts back on your face without washing it properly? No. So I ran a diaper service for 10 years. The standard was for sanitization was washing over 140 degrees. And honestly, any of the non-woven polypropylene holds up at that temperature, but it will break down. Cotton industry standard in the washing world was 96 washes. Would I trust that at your safety for a mask at that point? No, that's like breakdown done. So you're going to wash it in warm to hot soapy water, not too much soap, because if you do too much soap, there's not enough friction to clean the mask or any material properly. You'll have oversudsing, which means the bubbles are actually washing the bubbles, not your material. So you need to have enough mechanical action to wash your things. It's called a formula watch. So you need water temperature, agitation, temperature control, and hydrophobic. But if you don't have the right temperature, you can adjust it by adding longer time. If you don't have the right time, you can add more cleaning surfactants such as an OxyClean or something along those lines to make sure you've got a proper disinfecting level. So you can adjust it depending on what your circumstances are. Like in the diaper world, people were saying, oh, just put it in the dishwasher. Way back when people were saying, oh, you can disinfect your diapers in the dishwasher. Please no, that's a fire hazard. We saw that come through during the mask making. Yes, you can. No, you shouldn't. Keep it simple, stupid when it comes to laundry. Wash, warm, not crazy high fast spins, because that will break it down faster. If you want it to last longer, washing it by hand will last longer. If you have a high volume of masks in your rotation, that's one thing. But at a hospital level for sanitization, yes, you're going to want to go through, say, autoclave. So yeah, way back in when we were all using the H600, that all can go through an autoclave because it's all, and That's fold over elastic. And yes, it will go through autoclaves and not die.
Thank you. Now, Dr. Songer, I have a question for you. You have written a blog post on washing and disinfecting. Can you explain to us why we need both and when do we have to worry about the disinfection, given that we know it's pretty easy to kill the virus just by warm water and soap?
Right. So first, before we move on to that, I just wanted to add, I know Kimberly has mentioned it a whole bunch before, is avoid fabric softener. So don't use fabric softener in your masks. What it does is it adds a lubricant to your mask, and that just allows other goo to stick to it. And Kim could probably give you more on those details, but I wanted to make sure to throw that in for people who are laundering their masks with more traditional ways. Coming from a medical device perspective, the cleaning and disinfection of masks was a topic I didn't really want to get into, frankly, because it's a challenging one. And to meet the standards for medical device requirements, it's pretty stringent. And they actually require you to test for it to show that you've actually achieved the level of disinfection that you want. So in general, that's what led me to my initial advice in terms of mask disinfection, which was to boil the mask. And I recommended boiling for 10 minutes. The WHO and Passmore and a bunch of other organizations have also recommended boiling. And I did this long, deep dive into the exact temperatures and durations that you need to disinfect all sorts of different crispy critters. And as you mentioned, COVID is relatively susceptible to washing, right? So the detergents help break down and inactivate the disease. Well, sorry, the virus. And then heat and temperature can also help deactivate the virus. So a combination of those things does a pretty good job. But the durations and times and methods are really important. And so I thought boiling would just keep it really simple and easy. There are a lot of studies that show you take a PhD and put them in a room and say, boil this for this long, and it comes out disinfected on the other end to very, very large degrees of effectiveness. And you pick somebody randomly off the street that doesn't know what disinfection means, and you tell them boil something for 10 minutes, and what comes out the other side is just as disinfected. So it really is easily applicable. It doesn't require special technologies, and it doesn't have some of the challenges of disinfection through washing and detergent use and chemical use that Kim sort of alluded to, where what you're using as a disinfectant matters a lot, how much disinfectant matters a lot, what the water is to start with matters a lot. There are a lot of extra variables there. But that sort of ties in to what you were talking about before with the difference between cleaning and disinfecting. So the goal of cleaning is to get rid of dirt and soiling, and the goal of disinfection is to kill off as many microorganisms and pathogens as you can. And so those can be very different. And for medical devices, if you're going to reuse them, you have to do both, and you have to have very laid out fixed procedures. And for me, it was a bit of an education of going, okay, for general use, we're not talking about the sort of medical device hospital level of disinfection, but you need to find that balance of what people are willing and able to do that provides them the highest degree of certainty, essentially. And you need both, because disinfecting something won't get the dirt off necessarily. So if you boil it, it still can accumulate sweat, like salts from sweat and dirt and things like that. So I recommended sort of disinfecting before each use and cleaning once a week. But we've seen a fairly wide range of what is going back to one of the questions earlier that Barry said, what's good enough? How do you define good enough? And that's been a real challenge, whether you're talking about filtration or cleaning and disinfection strategies. So my preference still is to include some disinfection in there. And it seems from other standards and organizations that most of the time for people who are machine washing, that they're achieving good enough, both in terms of detergent use and amount, and water temperatures and durations and exposures. But that depends on access to resources. If you don't have clean water for your washing machine, if you don't have, clean water to start off with, then that can be a real challenge. And so depending on situations, you'll want to pay attention.
Thank you. It sounds like we definitely spend all day talking about washing. But I'm going to move on.
I've spent many days talking about washing.
We have about 10 minutes left. I would like to talk about lessons learned from this past year. Do you have any challenges that you have faced? What are some lessons learned, and what do you want to pass on to the, to the manufacturers as they are going to manufacture masks? What have we learned?
For the big manufacturers?
Anybody. What are some lessons learned?
But for people need to be explaining that a jersey cotton is not the same as a quilting cotton. Your lay person is not going to go, okay, these are the same. Your neoprene style mask versus a non-woven polypropylene, different. And for me, trying to explain that to people is different. I've got a son who's on the spectrum, and he knows his mask fits perfectly. He actually has a tan line from his mask for fit at school. But trying to get everyone else to understand that there's still a huge difference in mass-produced masks and filters and the filtration level and just a two-layer cotton that some people are using versus a medical, surgical, an N95. That is still a huge thing. For me, that's what I'm seeing still is a huge information gap.
I would agree with that. I would agree that in communication and top-down education about masks, because in this country we just started to slap fines for people not wearing masks or wearing masks effectively, but without actually educating people and a comprehensive campaign to teach people. So a lot of what we were dealing with was just steering the group through a lot of, I don't want to say misinformation, but information would come out from, the top down. So there'd be government messages, there was some guidance. For example, when trading standards came out, there was a big flutter. Everybody was afraid that what they were making might not be good anymore. And so we needed to kind of just help
corral them,
guide the group. Yeah, just sort of guide the group a little bit. But I think, and just to sort of to allay any fears that what we're making, it's a good enough mask. It is something, something's better than nothing. And I really like the piece about, any mask that you can wear properly for the amount of time you need to wear it for is a good enough mask. It's something that MIT Medical was talking about. And I completely agree with that. And the different masks for different tasks, I'm completely on board with this, Dr. Songer. I think that each person needs a big drawer that they pull out, and there's just like this almost buffet of masks. What do I need today exactly? And then we all have our favorites, right? So it's like, oh, I prefer this one because there's much more space in the front, and I'm I'm a teacher, I'm going to be talking today, I need the ones that allow, or, you know, Joan Fernley's beautiful singer's masks, you know, because we know now that these super spreader events from people projecting their voices, people can wear an effective mask and still have a level of protection there. Of course, at levels of issues of accessibility, just looking at your wonderful window mask there, you know, this seemed to be a whole element of society that was overlooked. The fact that people needed to read and use lip speaking and lip reading in order to communicate. So that was a very large part of the project that we were engaged in from about September onwards. And so accessibility, that's another issue going forward. And I just wanted to say one more thing with regards to, it was something about like, if we needed to, in order to speed up, we need to slow down. So it's about, you know, taking the time to really, to do the research and development, to do the testing. What are we looking at?
That is for your accessibility people.
Right.
There's stickers that I made for putting onto masks so they could tell people without needing to, that they needed to read lips.
That's a really good idea.
Because I've got a lot of people locally who are hearing impaired and need the lip reading.
Yes, yes, that's a really good idea. And we have a number of different lanyards that communicate different, you know, whether a person is exempt, for example. But I think that the main point that I wanted to just talk about was, because I'm not coming from an industry background or a science background, it's about communication, and it's about trust, and it's about building an environment that people can learn and grow in, which I already mentioned. And that is a place that is built and earned. And yeah, I feel honored that I got to be part of the group that we had achieved that, more or less.
Yeah. Can I answer the question about the seam line? So this is built off of a KN95 mask. So this is one of my original ones, and I did serge it. I have others that I don't have. Oh, there's one that I seam sealed, like a K95. Where am I? So I did Jocelyn was part of the seam sealing craziness that we did. So that's off of your K95 style mask. That's where Make It Labs created their mask that they allowed me to make and send thousands out to different places. And then it's best fit for whoever's wearing it and who's wearing what. And that education is huge. Like, I'm still fighting. My younger two kids actually wear masks better than a lot of people. Like, and like you said, it depends on who's wearing what fits. Like, one of my kids, this works for him. The one loop. Another one of them, they must have the 2-piece with an adjustable piece because their heads are different. And that's huge for, I've made so many custom masks because I have kids with special needs. They're ADHD, sensory processing. And like you said, the communication needs and the special needs communities, there's huge gap, especially with people with hearing aids. I made a whole bunch for the hospital that was surgicals with ties like this that I had to reserve out for elderly community members because all of them were going around their ears and they couldn't wear them without damaging their hearing aids.
So it sounds like it's very important that we do have different masks for different tasks. And it sounds also like education is still something that we're not there yet. We still have to try to educate.
A lot of education is still needed.
I would like to know from your perspective, what do you want from policymakers and regulators? Is there something they can do to help all of us, help the general public and help us educate people better or have a standard? What do you have in mind?
That's a loaded topic for me.
Dr. Soren, would you like to try?
I agree that that's a complicated one. I think sort of tying that into what we were talking about before is that we're all allies in this together. So certainly for a lot of the educational components, it'd be useful for policymakers and government agencies, as well as industry and our smaller efforts, if we could unify our messaging a little bit. And that was definitely a big challenge with this pandemic, is that everybody you asked gave you a slightly different answer depending on what field they were coming from or where they were coming from. And figuring out how to harmonize that is one of the big challenges. So I think in terms of policy, it would be useful if the agencies setting public health policy included more education and more of the rationale and reasons behind the guidelines and guidances that they were choosing, because I know that's been a big challenge throughout, is that everything's coming out so quickly. The time that you would normally take to devote to education and making sure that people understand the why behind the requirements hasn't been able to keep up. And so that's something that I think we can all work on and push towards together. And that's one of the places where having standards can start helping with that, help consumers and makers alike know the difference between the different masks for different tasks. Even just the use of the word mask has been loaded in this pandemic, and depending on where you are in the world, that is or is not an acceptable term to use when describing the face covering that you put over your mouth and nose for COVID. And there's been a lot of cases of semantics like that, where the words being used are loaded within specific fields, so people don't want to say it. And for mask, the challenge was the definition of mask implies protection. Protection from what? So that's one point of debate. And then how do you prove that it is protecting you from something? And so that's why mask was a word that people weren't using in a lot of cases. But you have ski masks and Halloween masks, and so there was has been this real divide between what the words that the public is using to refer to things, and then the very, very sort of cautious language of the scientists, regulators, and policymakers, and that's been a real challenge to navigate. I know I've struggled with it personally, and I've seen it's been tragic at times to see how that plays out on a national and global scale.
Yeah, it's, Jocelyn, do you remember my analogy for, it's like the footwear? You don't go up hiking up Mount Washington in flip-flops. So I made an infographic, actually my older daughter did, of your shoe needs to fit where you're going. So you can go barefoot in your backyard, but you don't go barefoot up a hiking mountain. So we'd had a shoe, then a flip-flop with socks, then a Birkenstock with socks, and then we went all the way up. And then in the bottom, she wrote something about, well, if your shoe doesn't fit the right size, you're going to get, it doesn't serve its purpose. So that was kind of my infographic in my head always during this, was we don't all wear the same shoes for every single day. You're not going to use the same masks for every single day. So it was like an infographic of, okay, you've got this whole different slew of footwear that is kind of universal. Everyone uses footwear for the most part, unless you've got my kids who are vehemently opposed. So it kind of, for me, that was my, okay, are you wearing a flip-flop type day, or are you needing a vapor barrier bunny boot that's the, like, up in the Arctic boot which level of protection are you needing for your foot is the same. That's kind of where I went for that. And I have to really give a big shout out to Becky and everyone that helped with the backside of organization, because I'm great with the ideas, the organization now, because That's, yeah.
Well, it takes the whole village to support.
Yeah.
Now, in this case, it's a global village, which brought me to the next thing is we're kind of low on time. So how are we on Q&A? Can I use another 5 minutes right now to discuss?
You sure can. Go ahead, Rebecca.
Thank you. I have a next question, which is, where do you think we're going? Where do you think DIY masks are going? I see less and less people wearing masks, at least where I live in Texas. Do you think there's a future for this if the pandemic is going to taper off?
I've been thinking about a mask subscription, actually, because I think that masks are going to be with us for a long time. Yes. And I think that in Asia, people have the right idea. And I think that's going to become the norm. People are already seeing improvements to their health with, reduced, allergies and dust and, even catching the flu, cold and flu. So I think that the benefits of masks are with us to some degree, whether people adhere to that or not. And I think it might become optional. I don't know. But I was thinking about, I'm always trying to think about what's next with this mask theme. And I think it would be quite nice to receive 3 masks in the post every season, fresh colors, even the technology can improve and what's latest in design, etc. And it supports the whole, the kind of the industry, so to speak. So that's just kind of on a maker DIY level, but I would like to see obviously more sustainability within manufactured commercial masks. And I don't know what that looks like exactly, but it would be brilliant to be able to wash them. And I participated in a washing focus group with Dr. Songer and Rebecca even and others. And, we were looking at hand washing and putting them in salad spinners and, treating them as gentle, and how long can we get this thing to go for? How long can this thing last? How well can we care for it, yet disinfect it and clean it? If I put it in a thermos and fill that with boiling hot water and put the lid on and leave it on my countertop for, 30 minutes, is it going to do the job? And we found, yes, it does. And, if afterwards, when it cools down, you add a little bit of soap in there and agitate it ever so slightly, that's a very portable disinfecting system, so I think this is a matter of education, but also I'd like to see technology moving along to support mask using and mask wearing as a norm.
Thank you. Actually, you brought up the agitating, put in a coffee thermal. I would like to give a shout out to Devin Ostrom, because he's the one that came up with the thermal idea. He actually has something called a 70-30 challenge. He says, we try to keep the temperature to be at 70 degrees Celsius for at least 30 minutes. If we do that, we can actually achieve pretty good disinfection based. I forgot what the log disinfection it is, but it would do really well. So try that at home if you want. Just disclaimer, hot water. So don't burn yourself, but 70 degrees C for 30 minutes.
That's about right for most of the pathogens that I would ever have had to deal with in the laundry industry.
I'm going to ask my final question. And for the future epidemic or pandemic, where do you see grassroots groups like us play a role? Do you see us as the leader, or do you think that we need to pass on the torch to somebody else?
I think, honestly, what I would like to see is more spaces like the Maker space, like Make It Labs in Nashua. They're kind of a community space of people with different knowledges. So they have mechanical, lasers, sewing, all of these different tech information. So where I got taught how to sew by my mom. I've got some background in chemical engineering, some background I worked in the pharmacy world, worked in different fields. And groups like us that so we've all created this amazing cohort of knowledge. And I think I would love to see the policymakers support us more. I would love to see maker spaces built into local communities. So all of this knowledge, like the sewing knowledge, we outsourced it all. All of the non-woven polypropylene and all of that, we outsourced that material making from locally. So that was a huge problem we had in the beginning, was getting the material, because we didn't have access to it and the ports were closing down. So by having all these different interdisciplinary people, I went, oh, wait, from my laundry world, I know what that material is, but my sewing people wouldn't have connected that. So for me, that's huge, is connecting and keeping these interdisciplinary fields and crossing these lines for the younger generations coming up to keep this thriving, that our minds just going, ooh, how can I improve this? Or what can I improve next?
Thank you.
Yeah, so I think that it's just sort of to wrap up a little bit, we've learned a lot about the interplay of fashion, form, and function, and the role of science in all of this. And there are a whole bunch of mask designs that are incredibly functional, but that people won't wear. The duckbill design comes to mind as one that has a lot of evidence that you can get a good seal on a large portion of the population. But for those of us who are making masks, we found that people weren't willing to wear them. And that if you can incorporate the elements of fashion and design into the mask, then people are more excited about wearing them. People like my mom, who's gone through and she has made masks for every season. They match her outfits, and she has a whole lot of them that can do that. And so I think while we're looking for manufacturers to help fill in and provide us with some of the things that we've gotten used to having access to by making them on our own, so there are some elements of fit that we're sort of looking for better options from the manufacturing. They have the access and hopefully the dollars to do the testing and to get things made to standards, which will help a lot. And there's been a lot of discussion about sort of the role of the different levels of standards. So there are N95 standards. Why do you need barrier face covering standards? And one of those reasons is that we are looking for masks for more than one task. And I've worn N95s for occupational settings, and they are great at performing the function they're designed for, which is filtering out all the really small particles. They historically have not been the most comfortable things in the world to wear. And as an asthmatic, I can tell you they're not always as easy to breathe through for long durations either. So figuring out that you can have this standard for the F3502 that's good enough for the majority purpose, which we're hoping to see going forward, which is more universal use of masks during flu season, or if you have a cough, please mask up before you leave the house. There's a whole market there that I hope is really going to grow. And by having filtration requirements that are more targeted specifically to the task of source control, that allows you to have a more breathable, more comfortable mask with more flexibility in a lot of other dimensions. So I'm really excited to see how the manufacturing world is going to adapt to what I hope will be an ongoing demand for masks specific to this task. And from sort of a maker DIY perspective, I'm hoping for a couple of different things. One of the things that we can do more easily than a lot of the manufacturers is really make masks for smaller targeted groups that have that don't fit into the larger population, right? So masks for people that are hearing impaired or that have sensory issues, or all these other sort of more tailored functionalities, and even masks that we can design to fit perfectly to our faces, because everybody on this panel and in this discussion has probably created that mask and has the mask that works perfectly for them, myself included. But it would be nice on the manufacturing side to see greater availability of fabrics and materials that have been tested, so that for those of us who are continuing to do smaller scale mask making efforts, we can sort of piggyback on each other's work and buy materials or material combinations that have been tested to spec. And that would be a really cool thing for manufacturers to kind of split off a side business for, or for other industries to step up into, because I think that we will see some ongoing demand for that kind of material and information.
Well, thank you very much. I think our time is definitely out. Thank you very much, all of you, for participating and giving us such good insights. I'm going to pass this time back to Barry so that he can help with the Q&A session. Thank you, Barry.
Thank you.
Thank you.
Great, thank you. And let me just see if we picked up anything in the way of Q&A on this session. Let's see. Hardos had mentioned that she noticed a seam in the nose line of the mask that Kim Leo was showing on the screen. Is that okay from the point of filtration?
So I know that Kim answered part of that. I think I have a few things to add. We've talked to a bunch of different testing labs, and we specifically had this conversation with the folks at Colorado State, sort of what impact that center seam has on filtration. And the answer is, it depends. So in general, if you don't have a seam in the middle, then you don't have to worry about particles filtering and slipping out through that seam. Beyond that, and especially in the DIY circles, it was a bit challenging, because if you give people materials and patterns, you get results with a whole wide range of sewing experience and ability. And so if you have a professional seamstress who has done a lot of work in her life and knows how to make a really good seam, then they tend to do a pretty good job. You can get the materials overlapping and you don't end up with a lot of loss through the seam. However, if it's not done well, then you can end up with an awful lot of leakage through that seam. And that's going to matter more and more as you get a better designed mask that more tightly seals to the face. So it is possible to make waterproof seams, which is what I was initially doing for the mask that had a seam up the middle, because that gave me some sense that I am getting a seal. And I had lots of fun, since I use water resistant materials. I could actually use my masks as a cup if I wanted to. And that gave me some assurance that I was getting a decent amount of overlap of materials to reduce the amount of particles slipping through. But yeah, there, as I said, there are trade-offs there. I think the mask designs that I currently prefer don't have a seam up the middle, because then I don't have to worry about it. Similarly with the heat sealed masks, that you have a real seal there. But for a well-constructed seam made by an experienced sewist who knows how to do it correctly, it is possible to get the 0.3 micron filtration that you're looking for from these standards.
Excellent.
If you are doing a design like a lot of us have done, where you're taking patterns and materials and having them done by a wide range of sewists, then you have to have good quality checks.
Okay, makes sense. By the way, somebody did comment earlier that when we were talking about the looking of a duck, that who says looking like a duck is unfashionable? So, just as a side note, I mean, there was a lot of duck. There's a lot of duck face going on. Exactly. There's a lot of duck face pictures going on before COVID. So I can't see why this is any different. Hardos had also said that, and this probably came during a particular line that I don't know where it relates, is do you believe the policymakers are ready to make use of such valuable information? I know the answer, my personal answer is no, I don't think that. But more comments from the panel would be a good.
I'm going to plead the fifth on that one and try to avoid conversations of a political nature.
So much safer.
I'm going to plead that people usually on the policy level maker don't connect with us at the real life level enough. There's not enough crossover between where people are making the policies versus real life application.
Makes sense.
It's not political, it's just the policymakers aren't playing down at the real life application level enough.
Understood.
And
for me,
I guess I will say something in defense of policymakers. In a lot of cases, people who are developing public health policy are weighing an awful lot of factors that the general public isn't aware of. And it is incredibly complicated to navigate these kinds of situations. And it isn't 100% what the science will do, because you're dealing with larger population dynamics and trying to predict how the policy you set is going to be enacted and how the population is going to react to that. So
I think
it's much more challenging than most people give credit.
And I think the harder part with that is also that the policymakers typically, where I come from, my kids have special needs backgrounds, is you're supposed to protect the most vulnerable. So trying to navigate that in all of this it's hard. I don't envy their job. It's like when you read, if any of your parents as well, when you're reading the labels on the side of a car seat, they don't make sense, but it's done as the legalese of it. So it's hard to get, I think, the policy plus the layman's terms at the same point. You can't get both.
Mm-hmm. Yeah, we always had to be very, very careful about what we said and how we said it in the group, because as Dr. Songer said, there's just a number of ways that message can be interpreted and criticized and analyzed, etc. And so I really think that it is a very tricky system to work within as well, and developing good policy. I think it is probably very difficult.
And the communication.
Yeah. During COVID, it was especially challenging because things were evolving so quickly and the stakes were so high. And coming from the background that I have with regulatory exposure, it was really, really challenging within the groups I was working in. For things that were outwardly facing, I'd want to have the language so that it wasn't wrong from a regulatory perspective, because you don't want to mislead people. But as Sophie and Kim said, the layperson language that you use to describe that is very different. And so that's one of the places where it really helps to have collaborations so that you can hear the same basic content from different voices with different perspectives. And being able to capitalize on that sort of network where we do have manufacturers and makers and representatives of the different user populations, as well as the scientists and engineers, all engaging in a dialogue, it can be incredibly challenging because we don't communicate with the same languages, even if we all speak English. But it's worth the effort if you can navigate through it, but it takes longer. And during the height of the pandemic, that time didn't exist. And so we're hoping that moving forward from here, where the pressures in many parts of the world are starting to ease up a little bit, we can take that time now and capitalize on what we've learned and the connections we've made so that we can move forward and not make the same mistakes again.
Yes.
Well, I want to thank all the members of the panel here. I think it was a great discussion. We got a lot of great questions out of this and a lot of wonderful information. And I want to say thank you all very much. We're going to move along. We're going to skip through the break to somewhat try to maintain ourselves on time here. And we're going to turn this over to Wendover, who's going to take us through a PowerPoint presentation. And like I said, thank you to all the members of the panel. It was really very interesting information. Wendover, if you're ready to present, we're here to good to go.
Hello, hello. Wow, what a terrific conference. Thank you. I'm so appreciate hearing everything you did, how you rose to the occasion. I'm so honored to be able to be participating from sort of a 10-year-old mask business perspective. I'll give you a quick little, I think I can share my screen, right?
Please do, yep.
Okay.
Down at the bottom there.
Yeah, and then I can go to, here's a PowerPoint. Here we are. Oops.
We see your screen.
Okay, very good. So in 2010, I was a partner in a publishing business, which we sold. My son.
Pardon me, Wendover. I want to go ahead and stop. I want to go ahead and stop you now and see if we can expand that screen a little bit. If you can go up to probably need to get you in a presentation mode.
Okay.
Down bottom right, you'll see a little thing that looks like a screen, projection screen. Push that little button right there.
There we go.
There we go. Excellent. Thank you. You're on your way.
Okay, very good. I was a publisher for 20 years, together with my husband and his identical twin. We sold that business in 2010. My son, who went to Columbia University and did a college engineering course, had worked in the business since he was 12. We sold, once the publishing business was sold, he came to me and said, what should we do? And I said, okay, I'll be a partner in a business with you, but it's going to have to further the dialogue about protecting the environment. So we came at Vogmask as environmentalists. And our goal was to create a tool to protect respiratory health, especially in the face of poor air quality, a terrific rise in allergies, dust, mold, and other particles in the air. We worked with medical device design engineers in Washington, D.C. to design a product that was reusable, number one, and efficient, which was confirmed by testing against regulatory standards for workplace respirators, and also comfortable to wear and stylish. How did we come on to masks? Well, we basically knew that there was a lot of conversation about the security of the water we were drinking and the security of the food, organic food that we were eating, but no one was really looking at how to protect everyday people, the consumer, from poor air quality. It's really interesting how it evolved over 10 years. And I'll just quickly let you know that once we had established a design and tested prototypes and started to develop a technical file and a quality plan in manufacturing, we established a sewing plant in Seoul, Korea. Okay, fast forward to last year. On February 28th, the sewing plant where we manufactured every single month for 10 years was hit with an export ban on certified mask products. Just to backtrack to one step, in the absence of regulatory standards for consumer filtering face masks, we always tested and in many regions certified the product. KF94, our manufacturing is governed by Korean FDA. KF94, we add the KN95 China mark on our product because we sold into China beginning in 2012 to address the air apocalypse. And then also the CE mark, FFP2, which also gave us the ability to not only do quantitative fit testing with sample test subjects, but also subject to paraffin oil testing for reusability and storage conditions. So here we are, February 28th last year, the government of South Korea responded to the pandemic by blocking the export of any certified mask products, hand sanitizers, or filter media. We worked with one of the world's leading filter manufacturers, innovators in Seoul to develop a filtering recipe, which is a sandwich. It has cover webs and a melt blown center, and which poses, as Dr. Songer has indicated, many, many problems in terms of reusability, washability, useful life. But it was our commitment to present to the public a reusable mask product that we could make some disinfection recommendations and also test both internally and externally number of washes. Ours are for the current F3502 certification or labeling, it's not a certificate. We've developed a technical file with 20 washes. We recommend washing once per week. The whole washing discussion is kind of beside the point, but we know that the product has migrated into the 50% poor air quality, dust allergens, a filtering face mask application, which tests against respirator standards, and 50% into the health providers. For example, we supply to Mayo Foundation, several orders per week, oncology centers, children's hospitals, transplant centers, and a number of other health providers and health systems that want to increase the compliance in mask wearing by having the cool looking mask. Now, I have to stop right here and thank all of you so much, because we had no mask imports from February 28th to June 15th, despite our efforts. My Congresswoman is Nancy Pelosi. She wrote letters to Ministry of Food and Drug Safety, Ministry of Commerce, Economic Trade. I blabbed it all over the international media that my products that I manufactured in Korea were being banned from export in the middle of a pandemic. It wasn't until June 15th that we were able to import our January, February manufacturing. These are all just manufacturing challenges, but thank goodness for everyone who rose to the occasion, and also so many sports and fashion brands who were able to quickly provide reusable mask products, because I've served on 2 different panels, one coronavirus technology solutions and 2 Waterloo Filtration Institute. All of our efforts were focused on filtering technology. We saw the rise of nanofiber mechanical filtering technology this year. It doesn't test very well for the microscope, the most penetrating particle size, 0.3 microns, as Dr. Songer has indicated, but it was testing well for, viral and bacterial. However, we're committed to supplying a product that was what our customer has grown to expect over 10 years, which is over 95% filtering of microscopic particles of mass mean diameter 0.3 microns, and also having excellent bacterial filtering efficiency and viral filtering efficiency exceeding 99.9%. But of course, as Dr. Songer indicated, that particle size is 3 microns. It's very easy to test well for not growing bacteria and virus inside your mask. Anyway, what I wanted to go, oh, should I change a slide ever? Okay, we were established in 2011. We're manufactured in an ISO certified facility in Seoul, Korea. It's a sewing plant. We source all of the materials within Korea. We have safety data sheets on all the material components, and we continuously subject each lot number to not only inbound quality inspection, but also to internal TSI port account, particle testing, and other tests to confirm conforming products. Over the course of the 10 years, we've been able to develop a quality management system, quality control, a manufacturing process, so that we were able to look at regionalizing manufacturing in other locations. So during the export ban, we quickly moved to train a facility in Germany for manufacturing Vogmask. And so it was very valuable to be able to sort of transfer videos, training, and a technical file and a quality system to other facilities. So those are gone through. And here's an example of like different health and safety requirements that what you guys call the manufacturers, and which I fall into, even though we're quite a small business. We're not, 3M, we're not making billions of plastic single-use disposable masks every single day. And we do feel that it's very, very important to look to a sustainable future, because all of our motivation of going into the mask business was to start a dialogue about changing our behavior for the sake of the planet. And my son and I have been able to lecture all over the world on the importance of reusable products versus disposables, and also global public health challenges of poor air quality. So this is just an example. I know it's not very easy to see because it's a screenshot, but this is one of a 14-page health and safety requirements checklists that are required by the CE certification system for respirators, or filtering face masks. They call them filtering face masks. Since then, last March 2020, a French organization developed the mask barrier, which is basically the same as our ASTM labeling system. We are very happy to test our product against respirator standards, but our goal has been to present a product directly to the consumer. And since we can't fit test the mask on every single consumer who orders on our Shopify site, we publish, quantitative fit testing on sample test subjects to confirm that the risk reduction in our product of the cross-contamination of microscopic particles is down between 2 and 8%. Generally, a surgical mask will be about 40% risk reduction, and N95 respirator, again, in the same 2 to 8%. So this just gives you an idea of what sort of technical file supports the very important characteristics of a commercial consumer mask product. But some of these things overlap with the new ASTM labeling requirements. So we were in a very good position to submit our products for that labeling. And one thing Dr. Sanger didn't mention, but is really good for us, is you're allowed to label on the packaging of your product under the newly published ASTM standard for face barriers. You're allowed to label what certainly the level 2, over 50% of particles of the most penetrating particle size, 0.3 microns. If yours measures 96%, you can put a little arrow on the label, on the packaging. So even if someone says, well, 50% particle filtering doesn't seem that great, you're able to indicate where on the 50 to 100% your product actually tests in a sodium chloride 0.3 micron particle. So, and then the ASTM standard is also interesting because it deals with some things that are sort of surgical germ mask oriented and other things that are respirator oriented. So especially with, cytotoxicity and flammability, these characteristics in the standard are the hydrophilic, hydrophobic characteristics of the materials is very valuable to the consumer when in terms of mask wearing going forward, to be able to be confident in the safety of the materials and performance of the product. So I gotta go on. So basically, I was asked to address basically where I see mask use going forward. Yes, I think mask use is now normalized and people are not going to look askance at you for wearing a filtering face mask in a grocery store from here to the end of your life. But this is where aesthetics are very, very important too, because especially we found in 10 years, the very easiest adopters have been under 10 years, kids who have worn a mask to school, whether they have genetic respiratory or other health issues that the mask can be beneficial. But we see, we've always targeted all of our communications without overclaiming the product and very carefully with the proper, language so as not to build any false confidence in the product, that our product is designed for, particles in poor air quality, dust, allergens, particles in poor, from vehicles and cars, germs, shavings like wood shavings, biologics, odors, scents, mold spores, especially wildfire. We are going into a wildfire season probably that is going to be severe. And our masks have always been sort of the gold standard for keeping those particles, especially out of younger lungs where respiratory damage occurs more quickly. Volcanoes, we've been able to support humanitarian efforts in the Philippines with the volcanoes, in Bali with a volcano, in Hawaii, and other contaminants. I know I'm trying to go really fast because I know I only have 10 minutes. Anyway, certainly we feel that offering in a variety of designs, as you guys have also seen in the do-it-yourself masking, has been contributed to high compliance in mask wearing. We offer 5 sizes from, basically the small will fit a 3 to 7, 8, or 9-year-old, then medium plus, large, and extra large. So we do as much testing as we can, but the way that we confirm each consumer of a Vogmask has a well-fitting mask is we do a no charge replacement for a wrong size. So any Vogmask customer need only contact us that they don't think it's a good fit. We send the next size up or down to try to resolve that. If we can't get a good fit, we refund. They don't need to return a wrong size mask, because there's no point in returning a mask that has no value to anyone, polluting the environment. And then also, we test for breathing resistance. Obviously, we're not going to measure level 2 ASTM for breathing resistance. Ours normally will measure in the 9 to 10 column height of water, inhale, and 8 to 9 on exhale. The allowable range for a particular respirator, for example, is 0 to 35 on inhale and 0 to 30 on exhale. So, but the new ASTM labeling requirement is much harder to pass. So we will measure certainly very well in the level 2 for particle filtering efficiency, but the breathing resistance will be in the level 1 at 9, 10 airflow resistance. So, but we feel that, you know, collectively, all of our ability to share information and address a very large tidal wave of climate change coming forward is going to help us design, create, manufacture, and distribute products that will protect public health, and also with the reusability, protecting the planet of the future, because we now have billions of masks, single-use plastic at the bottom of the ocean today. Some of our materials are sourced by combing the ocean floor for plastic and repurposing into non-woven fabrics. So let's see. Here, mask use in the future. I'm almost done, so you can ask whatever you want. We must have reusable mask products. We're already changing all of our information. People are mask fatigued. They're tired of wearing masks. They're tired of talking about it. The mask trolls in social media are getting more and more angry and horrific. And so we are sort of migrating to the mask as a way to protect public health going forward. We have to replace single-use disposables. This isn't going to happen in medical, where NIOSH already, or OSHA already mandates 1 mask each patient or hour, whichever occurs first. And so the single-use disposable mask products should be reserved for those applications. Sustainable material components, where we've been working on filter technology, where you could take from a sheep to a compost the same filter media. It's difficult to achieve reusability and washability in that media right now, but we're getting better and better, and that's part of our research. Obviously, we have to protect the heart of our planet, which is the ocean, and, you know, address climate change so we can have technology to, you know, we all have kids and I have grandchildren. I can't, you know, we have to deal with it. And obviously, if your mask can be used for 90 days, there's a much lower cost per use than a single-use disposable anyway. So anyway, with the F3502 labeling requirements, we're thrilled to have, you know, regulatory address consumer masking. Innovation has always led regulatory. This is why we turn to workplace respirator standards to confirm the safety and efficiency of our products. But now we can migrate to, you know, show we have an excellent reusable product that it also raises a dialogue about how to protect the planet. And that's all.
Wonderful. Thank you so much.
Yeah.
All right. We're going to go ahead and move on. We're running a little bit behind, so we'll just move right into our next thing. And I'm going to introduce Dr. Songer again with Kimberly Sky from Unicorn Breathing Mask. and then we'll move on to the panel after that. Dr. Songer? You're muted.
Unmute myself. Hi, everyone. Nice to meet everybody. Oh, Dr. Songer, I love you. You're a sister. I can learn so much from you. I love this panel. Thank you for having me on. I don't know how much you guys know about little old me because I just started a year ago out of necessity. I put on an N95 mask and I could not breathe. I started to suffocate. I'm very sensitive. I'm an empath, indigo child, starseed from somewhere else. Anyways, I put this thing on and I was like, I'm in trouble. I'm in serious, serious trouble. So then my mom called me 911 and she's almost fainted putting on an N95. So I realized we've got a problem because she's got a pulmonary condition and I had to help both of us. So I went badly looking online. I was looking for an organic mask, something that would be safe and protect me because I'm 100% organic in everything I consume and put in my house and on my body. So I couldn't find anything. Unfortunately, I just wasn't finding something that was as pure as I was looking for. So I realized I needed to step in and do something. And I started utilizing all the contacts I had from the entertainment industry because that's where I came from. I was a singer, songwriter, and actress, and you know, consultant for the entertainment industry for a long time. So I just reached out to everybody and anybody I knew. I reached out to a Milano Italian designer. I reached out to all these different people, and I ended up finding a manufacturer for masks who had been in the business for 5 years, and you know, was doing a lot in Asia, in Indonesia in particular. So found them, and I was like, okay, you guys, I love the fit of your mask, but it needs to be organic. And I need to change the materials around because it's got to be healthy. So we worked together as a team. We worked with 3 different countries: New Zealand, Indonesia, Italy, and here. And all of us came together, just like what you guys are doing, and ended up creating what is now called the unicorn mask, because I'm a unicorn. So it's like, why not call it unicorn, right? So it's been a whole process. It's been a whole journey. We are using the nanotechnology that Dr. Songer mentioned, the electrospun nanotechnology. And it is, I can share my screen if you guys just want to see a little bit of what it looks like close up, if that would be helpful. So I'll quickly, yes, okay. Okay, great. So I will share my screen really quickly with you all. And I know there's so much to cover, so it's really challenging. We have a little bit of time here, but this is our little website we put together. And here you can see kind of what it looks like under a microscope at 10,000 magnification. The reason why we went with this nanotechnology company in New Zealand is they are the only nanotechnology company in the world that doesn't put additional chemicals in the nanofibers. I was really careful about that because I wanted something that was very pure. So they don't add any sort of antibacterial additives or anything to the polymers, which is really, really important to me. This is what a standard nanotechnology company does with the fibers. So you can see there's gaps there, okay? And I didn't like that. I don't like that at all. So I said, okay, we need to fix that. So what we did with Revolution Fibers in New Zealand is they have a way of electrospinning this, and I won't go into the details unless you guys want to know later, but they have a way of electrospinning this so that the nanofiber is thinner in diameter, thousands of times thinner than a human hair. And they layer it, so many different layers. There's so much depth to this that you can see this is magnified the same level. You can see these big gaps are closed for the most part here because there's so many different layers. And they also manage to, it allows for maximum breathability as well. So just to give you a little bit of information about what a nanofiber is, I just wrote this out so that I could read it to you guys. Nanofiber is a textile made from extremely fine fibers They're typically 10 to 300 nanometers in width, which is 10 to 100 times smaller than that of conventional melt-blown microfibers, and 1/500th the width of a human hair. These fibers are spun into layers. These layers are put together to form filters. Nanofibers are particularly effective in stopping submicron and nanometer contaminants with minimal impact on pressure drop. The membranes are made through a process called electrospinning. So you can kind of see this really short video of what electrospinning is. And it's involving dissolving a polymer in a solution, then using an electrical current to move a droplet of polymer downward through a needle at room temperature, lowering energy production costs. As the droplet accelerates, it stretches into a very small fiber that retains a static charge, retaining much higher filtration capabilities than melt-blown over time. Electrostatic capabilities that melt-blown filters rely very heavily on are largely lost after the mask is washed or once it gets damp from breathing. And you know this because you've seen the N95. It only lasts for about 8 hours, right? So every hour you wear it, it reduces in filtration efficiency. So what's great about nanotechnology is while nanofibers lose some filtration, they often retain a far higher efficiency and are therefore reusable. Melt blowing typically produce fibers with diameters in the range of 1 to 10 micrometers. Its structure is like a non-uniform fishing net with pores 1 to 3 microns in diameter, much larger than viruses, which tend to be at 0.1 microns. Additionally, melt-blown filters are typically made of melted polypropylene passed through a small nozzle. The resulting filaments are blown out at a high temperature and speed, then cooled in the air. A disadvantage is that only thermoplastic polymers can be used with melt-blown. It is also difficult to control fiber size in the melt-blowing process. This can lead to uneven flow of melt, making the fiber thickness uneven, affecting the breathability and filterability. The higher surface area in nanofibers induces better filtration efficiency, largely because surface interaction is the dominant driving force in air filtration. So that's a little bit of a background on nanofibers. And this is a little graphic that shows the difference here between a nanofiber filter and a melt-blown filter. You can see breathing air and moisture transmission. I don't know if you guys can see that okay. And the breathing CO2 transmission, just kind of the difference if you're looking at an infrared thermal camera. So that shows the breathing comfort. So when I was evaluating what type of technology to put into this mask, I was really looking at the difference between melt-blown and electrospun nanofiber. And when I was looking at this, and again, I'm not a scientist, this is just a layperson trying to figure out what is going to be the best option and the healthiest, safest option. I realized that nanotechnology gives us the high particle filtration efficiency and the high breathability. And for me and for my mom, who has the pulmonary disorder, the breathability was critical. So we needed to find something that could filter but still maintain a high breathability. So that is why we went with nanotechnology. Now, one thing I'm very passionate about now that I've gotten into this for a year is creating a green polymer. Because right now, the polymer that we are utilizing is not what I would consider green. It is safe, it is non-toxic, but it is not what I call green. When I think of green, is something out that you can find out in nature. So what we're working on now, and is very exciting, we're in the innovation process, is electrospinning a green polymer that is from nature that still maintains a high particle filtration efficiency at 80%. And a breathability at also high, so at a low level 2, which is what we're working on right now. We're in the process of testing, and more than likely we will be launching that the beginning of next year. And in the meantime, we have another filter that we're working on, because right now we're at a 50% particle efficiency for the new standard. We have had a little bit of issue with the testing, and the reason for that is because we have this lovely chin wrap. And this is what makes this mask fit amazingly well. So I can just put it on and show you guys. really quick. The chin wrap just fits very securely with the spandex and soft. It's very soft cotton material. And you can see it just fits right on all the way underneath the chin. So it allows for this, for very little gaps and leakage. I don't know if you guys can see that.
Kimberly,
Okay.
can you talk a little bit more about the challenges you had with the testing?
Yes, so I will talk more about that. I just wanted to show you guys this fit briefly, why that's important. So the challenge we're having right now with F3502 is the lab, when they go to test it, they put it on a mold, right? And what they did with our particular mask, they didn't think about this little guy. So they put it down on the mold and they glued it with this little guy not tucked underneath. So when you do that, obviously that's going to affect filtration efficiency. So we got a very low rating, and we're like, what is the problem? Because we've rated it with an F2299 test and we performed very high, but then when we performed with the F3502, something was wrong. So we went back and forth with a bunch of different people. I mean, I can't even tell you how many people we've spoken with about this, including ASTM, but we realized that the problem was that the current test is not accounting for every single type of mask design, right? So it's, the current test didn't factor in for something like this with a chin wrap. So
if I can jump in just for a second, I know, Jocelyn, you had a similar set of challenges with the flat plate.
Yeah, so one of the things about the ASTM F3502 standard is that it tests the whole mask. And so, and typically what they do is they glue the mask body onto the mounting bracket around the outer edge. And so for me, I ran into a challenge with the mask design I have is designed to fit on a very contoured face.
Yes.
And when you try to mount that to a flat surface, there are some challenges. And so there are pros and cons to this. For product development phases, it's good to test the fabrics themselves so you know sort of what your maximum performance level is going to be. One of the challenges with a lot of mask design like yours and for masks that have insert filters is knowing what portion or surface area of the mask is actually going to be sealed to the face. So for masks with insertable filters, a big challenge is that the unsealed or the area around the filter itself isn't sealed to the face. So the ASTM standard is designed to test essentially for that case so you don't overestimate the performance of the mask. But if you have a mask that is designed to seal on the chin but has an extra comfort strap, there's no or surface area that's just for comfort, but the seal happens above that, there isn't a way to account for that within the standard. And that just gets to the challenge. It's sort of like a square peg in a round hole.
Exactly.
And
Really
so the standard is testing things mounted on a flat plate where instead of a face, which is a complicated issue because faces come in so many different sizes and shapes. So I think there isn't a great solution to the problem yet from a testing standpoint.
They are working on a revision. So yeah. But in the meantime, we are not letting that deter us because I mean we are supplying masks, the American Federation of Teachers and some other organizations such as that. So we do feel the standard is being revised. They're looking at all these different mask manufacturers and they're realizing, ooh, here's some challenges here, here's some challenges there. I think what's really important though is that as mask makers, that we really stay true to what we know we have, what we know we need to create for folks. Because at the end of the day, we're here to help people. We're here to really save lives, and we're here to give people a helpful, pure breathing option outside of an N95 if people cannot wear those. So I think it's important that as the standard's being revised and as it's being modified, we still stay true to our vision and what we know we need to create. And if we know we're hitting those marks, those benchmarks for filtration, efficiency, and breathability, awesome, keep going. You know, the standard will be revised. It will be able to account for all different designs and styles of masks. And like somebody said so eloquently, you know, there's a mask for every occasion. There's really no competition in this space. You know, you really need to have one of all of these masks in your repertoire and use them for different uses and different occasions. People love to use ours on a plane because they feel super safe and they can breathe easily for 5 hours. You know, essential workers love to use this because they can breathe easily in it for 8 hours and it's protecting them. And really too, I would say the other thing that I've really discovered I'm very passionate about is the importance of using organic fabrics. I know that Wendover also uses organic fabrics from what I can see, what I've seen. And so it's just, I would encourage everyone to go that extra step and really not only an organic fabric, but really look at the origin of where it's coming from. That's extremely important because there's, for example, some mask makers use bamboo and they say it's natural, it's organic, but it's not. It's rayon and it's not. It's a synthetic. So really, like doing the research on those textiles, GOT certified is the way to go for fabrics, and tracing their origins and tracing their country of origin. Where are they coming from? We don't like to use fabrics from China because even if it is certified organic, sometimes we've found traces of chemicals on there. So we really like to source our fabrics from a truly organic place that is not spraying anything. And we spend a lot, I would say for my job, I'd say about 80% of my time is spent sourcing fabrics, literally. And then plant dyes.
Sky, can I draw us back? I want to hear a little bit from Wendover about your process of going through the testing for the most recent ASTM standard. I know you've been going through that process recently, and what were your thoughts on it as well?
Okay, so we are actually right in the middle of building the technical file because we've relied on a variety of test standards over 10 years to confirm our efficiency. So we haven't started labeling with the ASTM F3502 marks yet. This is what we've done so far. We're testing 10 organics clean and 10 organics after it took us 2 months to wash them 20 times. They don't, at Nelson Labs, they will do the preconditioning for washability for you if they can machine wash. Our maintenance instructions are hand wash by rinsing under tap water at a small drop of liquid soap, like you might hand wash dishes with. Rinse both sides and then hang to fully dry before any sort of storage or putting in your purse, pocket, pouch, anything. So because those maintenance instructions, which we publish in our user instructions and also on our website, are unique, and Nelson only provides for throwing it into a washer and dryer 20 times repetitively. We had to do our own well-documented, video-documented washing tests. So basically, we have submitted to Nelson 10 organic cotton masks, which are both sprayed every single day over 2 months with over 61% alcohol spray, and for 10 days at 10 times. And the rest of the time we did wipes, which is our recommended maintenance. That was the only disinfection which we have internally tested so as to confirm it doesn't affect the filtering efficiency of the product. So we don't recommend rice cooker heat, UVC, PAP, hydrogen peroxide. We haven't tested that on our product. So as a manufacturer, we can't recommend it. And we also know that over the course of this pandemic, the tactile transmission of the virus was actually a very low risk. We quit washing our groceries and spraying off our Amazon packages. And we know that the risk of contamination of this virus was basically aerosols. So we were addressing wash your hands before you put the mask on, and wash your hands after you take it off, so you're not transporting a live viral particle. But the fact is, in our testing for the ASTM, we have several series going, but right now we spent 2 months washing and disinfecting the organic product family and washing and disinfecting the microfiber product family.
Well, it'll be very exciting to see those results as they come back.
Absolutely, we'll publish them. We always publish all the audits.
That'll be great to see. Now, can I ask you both Wendover and Sky, can you talk a little bit about some of the obstacles you've run into in terms of manufacturing of the masks?
Yes, I did want to mention one other thing and follow up to what Wendover just mentioned, and that is Intertech Labs, which is who we use. They will wash your mask for you 25 times or whatever time, however many times you want to go up to. Intertech, our mask is hand wash only. We do ask that you remove the filters when you wash them. So if you guys are looking to get the F3502 test done, I would recommend maybe go to Intertech if you want them to wash it for you and do it responsibly and follow the instructions to a T, including if it's hand washed. That is helpful because we have washed our mask 25 times ourselves. It's very time consuming. And I would also recommend to mask manufacturers, if you are going to have the lab do that, make sure you send them a video and show them exactly how you want them to hand wash your mask. Because if don't rely on their interpretation of your instructions. We learned that the hard way too. Just send a quick video. They're very good about it. They will hang dry them. They will follow your instructions to a T. They will use mild organic detergent, whatever you want them to do. They will do it, and they will do it for you, and it is helpful. And I believe our testing ran in around 3,000, I believe it was, for them to do it for us, which was very reasonable. Now, we were one of the first people, so maybe their pricing's changed, I don't know, but it was a very reasonable cost. And they're also redoing it for free now because they realized they made that mistake. So their customer service is phenomenal, and I would highly recommend them as a lab. Okay, so going back, sorry, James, I just wanted to mention that because I know you're maker.
I was trying to move us on to something. Yeah, a little bit about manufacturing, but it's good to really talk through this testing piece because this is the core of these masks, right?
And it's the most challenging piece where there's a lot of things that we've had to learn the hard way and the expensive way, I would say. So if I can if I can help you guys in any way, I will with that if you have any questions about the testing. So challenges with manufacturing, we were lucky because we worked with the manufacturer who's been manufacturing in Indonesia for 5 years, and they have multiple production lines set up. We can make up to 500,000 masks a month. And we were actually getting ready to potentially supply the CDC with masks right before they lifted the mask mandate. Again, politics, you gotta love them, but yeah, so we can do that with Indonesia. And the great thing about Indonesia is that they don't often, there's not really a border closure issue with them. They supply a lot of the world's textiles, so they tend to keep their borders open. There was a brief time when there was a little bit of an issue, but we managed to talk directly to the consulate and get past that. So as far as other challenges, I would say maybe the biggest thing is when you are sourcing organic fabrics and you're doing it at a large scale, that can be challenging. So that, we have somebody who's full-time dedicated just to making sure that fabric supply is steady and that we have plenty of it. Their job every day is to check on that. What are the order inquiries coming in? Do we have enough of this certified organic fabric to meet that demand? Yes or no? What are backups? We always have backup options constantly. So that's probably our biggest challenge. And I would say the healthier you go, the harder it is, including with plant dyes. We have a smaller plant dye manufacturer, But so if we were to get 500,000 K a month, that would be a little bit more challenging to meet that demand. So we're always looking for, I would say it's always a good idea to set up multiple back burner manufacturers for things, just in case. You just never know what's going to happen, right? And especially if there's another surge. So that's my 2 cents.
And you, Wendover, what were some of your experiences with manufacturing? What are some of the challenges you ran into?
So we have manufactured in the same plant for 10 years, since September 2011. And so we've been able, most of the challenges are implementing changes, because we've always innovated based on customer feedback. And we've had to be very careful when we were revising the noseband or revising the elasticity of the trim and ear loops when implementing a head strap alternate head suspension. The most challenging parts are sort of qualifying, testing, and implementing changes, because we don't want to fix something that's not broken. However, we know that there's a lot of room for improvement in the product. Secondarily, we felt that we were unable to manufacture to demand, but we lucked out that the Korean FDA has to certify any masks manufacturing plants, and the upstairs of our plant became available. So we were able to increase capacity to meet new demand last year. That was but by far and away, the biggest manufacturing challenge was not having any imports from February 28th to June 15th. And we couldn't even, we had to close our website. We designated all of our on-hand inventory to charitable relief and humanitarian donations. So we went 4.5 months with no manufacturing access at all. And that was a big challenge, but we're over it.
That sounds very tricky. So it sounds like in both cases, getting access to supplies and raw materials, right, for your feedstocks in terms of fabrics was really where the challenges lie, right?
Yeah.
In my case, we have, of course, qualified all the suppliers of the material components, and also submitted those components to material safety data sheets so we can confirm no chemical, and safe for respirator materials. One thing about the nanofiber technology, which has a lot of promise, it's not allowed in Korea so far. The Korean FDA has not certified nanofiber filtration technology for respirators. It'll come, but that wasn't really an option for our Korean manufacturing site. So, in terms of raw materials, it's the most important is the filtering technology, and the rest, having a global organic textile standard certified organic cotton, we're sourcing that in Korea, but organic cotton is abundant in other places. Certainly India has a subsidized organic cotton industry that's very vibrant, and the certifying body is actually in the Netherlands for those materials. So I don't know, it's that last year was a weird year, and
Wendover, you said something in there that was really good, or what I heard is you really try and drive your changes based on customer input, right? In terms of what are those key characteristics. So can both of you tell us a little bit about what you hear from your customers as what are the really important aspects of reusable masks?
Yes. Sky, do you want to go first? I'll go first.
Go first, sure.
We've stayed very, very close to the customer, even though I have 23 international resellers. We have, especially with the US market, which is our biggest market, we review and log every single customer feedback on the product. So we can rank it for severity, frequency, risk, and those quarterly reports drive what we feel we must do to improve the product. So basically, all of the issues surround comfort and fit. And their especially suitability of materials. We get everything from the organic cotton is itchy on the face to the ear loops are bending their ears forward too much. We've certainly looked at adjustable ear loop options, but we don't want to compromise the comfort of the product that we already produce. So it's not really clear that a thinner ear loop with a little adjuster on it is a suitable alternative. Basically, we've stayed close to the customer by reviewing all of the contact emails. We have a customer service staff who does wrong size replacement and transmits, a Zendesk of information, but every single thing that is feedback that might influence innovation is flagged for us to review.
Fabulous. Sky, tell us about your experience and sort of how you're bringing back information from your customers and tying it in. What are those important characteristics?
Well, when we set out to create this, the first thing I did was look at the existing mask companies. Wendover, to be honest, yours wasn't included. I'm just, I looked at a bunch of mask companies, and I looked at the common issues and complaints. And then I took that to the Italian designer and I said, we need to fix these. So that was the first thing I did, is I started with the complaints in terms of, comfort and fit. And so for us, doing the adjustable ear loops was critical with the little dongle, accounting for this, for people with beards, right? There was a lot of beard issues. So with this one, allowing this to tuck in the beard and seal it and maintain a seal there was important. So I really looked at all of the complaints and I said, we're going to solve all of these before I even launched. And we did. We solved a lot of the problems. And then we did an essential worker test where we gave away free masks to a ton of essential workers and said, what are the problems you're having? Some of them wore it for 2 hours, some of them wore it for 4 hours, 6 hours, and then 8 hours, 5 times a week, 2 times a week, 7 times a week, 7 days a week, and tested. We gathered all of that market research, and surprisingly, what we found was that people were very happy with the solutions that we solved, the common complaints from mask wearing, and they loved it. I mean, in fact, a lot of the times we got stuff that's people saying, I forgot I had it on. I literally forgot I had it on. So a lot of people say to us, you know what? I want to wear it all the time. I don't even want to take it off. So we listen. There are the few complaints that come in, but we're lucky that we had this designer who worked with Armani for 35 years. He was just an expert and was able to address these issues. And we're very happy that our customer complaints are very low. Every now and then we get somebody who may be an extra large, and all we offer is extra large. So in cases like that, I've literally created a custom design for that person. And we just did it. We're like, okay, don't worry, we got you. Even though it was only 5 masks, I called the designer. I said, listen, we need to do an extra large for this person. I hope that's okay. And they're like, well, it's okay, but you're going to get it in 3 weeks. I was like, I'm okay with that, but just let's do it. So whatever complaint comes in, whatever comment comes in, we do it. One lady, we had a kids mask design, and it's called Unity Stars. It's black and white stars. And she's like, I want one so badly. I want an adult version. And so I listened. I said, okay, you know what? Next shipment, we got her what she wanted. So we're small, so we're able to do that right now. I'm hoping we can always do that, but we have a live chat 24/7 customer service team. I literally look at every single comment that comes in. I get a report every night. I look at all of them and I respond to them.
It's great to hear that both your teams are really going after, being responsive to your customers. I think it makes a big difference, and I also think it helps your product evolve over time. Talk to me, and I've heard both of you guys speak to this, about what are some of the big advantages of having a reusable mask, right? Why does it matter that we make reusable masks and not just have, one-use masks? And where do you see this really matters in the market?
Wendover, do you want to speak about it first?
Sure.
Certainly from the first day, our objective was to present a reusable mask product, and basically to protect the planet from pollution. And we've designed all of our processes to make sure that we weren't contributing to the problem we're trying to solve. And so especially if you can prove the reusability of a product up to, over 3 months, because the acquisition cost is sometimes prohibited in some regions of the world, you're still able to offer, a conforming level of efficiency across 90 or 100 days of usage. So it's all the environmental impact, and that was our goal. Certainly, I talked about the single use in medical applications. I don't see that going away.
Mm-hmm. Skye, and then Jocelyn, because I know, Jocelyn, this is something you've really paid attention to as well.
Yeah, so for us, I mean, it's the environment. That's my number one care and concern, naturally. So that, but also it does make financial sense for companies. If they are following N95 guidelines for instructions of use, which they very well should be, although I know a lot of them aren't, that mask needs to be disposed of after every shift. And so if you look at this from a pure financial standpoint, if they are following the instructions correctly for their employees, it makes more financial sense for them to purchase a reusable mask. And we are very effective at, presenting the financial argument, because at the end of the day, that's what a lot of these big companies care about, is the bottom line. And as a reusable mask manufacturer, it is challenging for price points, especially as you use healthier, safer materials. The cost goes up, right? And you still have to maintain being competitive. But we really use that argument. We price out, here's what it's going to cost you if you're following the guidelines, using an N95, having every employee throw it away at every shift. And here's what it's going to cost you to get into a unicorn mask, still have safety, breathability, where they can actually breathe, where they actually enjoy wearing it, where it looks fashionable and good. Okay, a lot of millennials care about what they look like when they're wearing these masks at coffee shops, servers, so that's important. So just presenting that argument from a financial standpoint, because they don't care about the environment as much as, we wish they did. So I speak on the language that they can understand, which is the pocketbook. Meanwhile, my heart is invested in the environment and knowing that I'm doing good for the environment. So I wish that argument worked for them, but it doesn't. So we have to approach it from the financial. Here's how it saves you money.
Jocelyn, I know as your team approached this, you guys really had a focus on reusability. What were the driving factors behind that?
I think, like everybody else has talked about, the environmental impact is something that everybody should be thinking about every day with everything they do. And with masks, that's especially true. I think there's also a convenience issue as well for a lot of people in being able to have reusable masks around that you like and are used to. And if you can achieve the same public and environmental health standards using reusable masks and sort of pushing that field forward so that we can gain broader application and broader use and get global adoption of reusable masks in situations like we're in now with the global pandemic and these public health issues in terms of infection control, but also as we're seeing more and more issues with global warming and smoke and fire and air pollution. So all of these issues are related in a lot of ways, and having more options on the market that people can turn to instead of what most people have done during this pandemic anyway is, you know, the little blue disposable masks that actually aren't tested for anything and aren't safety checked at all, but you can get them in mass quantities and then they end up all over the place. So it's really great to see people innovating and coming up with solutions both in the smaller sewing spaces and maker spaces, and then watching those evolve into small businesses and trickle out to even larger manufacturing. And the trade-offs, as we said before, the different masks for different tests, having really high breathability is great in contexts where you don't need 95% filtration, but 50% filtration is good. But there is a trade-off there. And so the higher filtration you go, the harder it is to meet those breathability standards. And the more frequently you're going to want to be changing out your masks too. So it's all related, and it's great to have lots of different options and perspectives as we hopefully move the field forward and get the regulators to catch up.
Now, an aspect of mask wearing that is near and dear to my heart. My mother is quite hard of hearing. And so she does a lot of her understanding of communication by way of lip reading. And so masks clearly are a challenge in that environment. If you can all, maybe starting with Dr. Jocelyn, if you can speak a little bit to your efforts to deal with accessibility considerations in relation to masks, I think it'd be really interesting.
Yeah, so we've spent a lot of time looking at accessibility issues, and we've had lots of sort of small population segments reach out with their individual concerns. For hearing related issues that cropped up in my family as well. My dad wears hearing aids, my grandfather wears hearing aids. They're both hard of hearing. So there are sort of two different approaches we've seen and we've taken to address this. One is looking at mask acoustics. And it's come up a lot in the discussions and in sort of the focus groups of people trying out different masks and designs. But you do get different acoustical properties depending on the materials you're using. And that's not something that's tested for regularly or evaluated, but can be a concern. The attachment points that you mentioned before is also a thing with the hearing aids and also with people who have impaired mobility. So often you get a better fit with the head ties and the around the head straps, especially if you're trying to get sort of universal fit. But that's harder for people with mobility challenges. So there are all sorts of different aspects there. And then for people who rely almost exclusively on lip reading, we've seen in the DIY segment and the maker world, a whole bunch of these window masks or masks with the windows. And that brings up a whole new can of worms in terms of what materials you use for that window, how you get that window attached into the mask body, and then making sure you have enough breathable surface area of your actual filter material, because none of those clear window materials are filters. They are solid barriers like plastic bags. And if they've got little holes perforated through them, and I have seen some that do that, then that's not filtering at all either. So there are definitely a lot of challenges there, and I think it's a hard problem to do well. And from a fashion perspective, we also got a whole bunch of feedback that people do not appreciate the way they make you look because they look a little funky. So there are a lot of design issues that I think are going to require work to move that particular direction forward.
Skye, can you speak a little bit to some of these considerations and how your team has approached this?
Yeah, I have seen some masks that are coming out now that are made of a silicone material with a built-in speaker system. So that's something you might, yeah, I forget what it's called now, but they haven't done it yet. The challenge is, how are they going to pass the F3502? So that's where the challenge is, and that's where their struggle is currently. So the way we tried to solve this is, for me, I really cannot stand having fabric suck into my face on any level. It's just, I'm very sensitive. So for us, we put this strong reinforced center stitch so that the mask protrudes outward. And that allows for a lot of room for speaking, especially professional speakers like our mask for that reason. Now, again, you can't read the lips, but you can hear acoustically the voice protrude out a lot easier. So for essential workers, their main job is communication. They have to be able to talk easily without fabric sucking in, and you have to hear them. So we did test that when we designed this, and I did protrude out the center stitch and reinforced it even more so that it would allow for even more space, because our first prototype, I still felt like acoustically I couldn't hear the person. So we modified how much this protrudes out in order to achieve that. But again, I realize there are so many issues along with this. The adjustable ear loops, I think, is also very important to account for. You know, my uncle has cancer here, and he had to have part of his ear replaced. And so there's a issue he has right now where he has to use this adjuster in order to have this mask fit to his face. So thank goodness I had this, because he's able to wear the mask now, and it fits over that thing he's got on his ear right now as he's healing. So I do think it's important to have adjustable ear loops for that reason. But there's a lot of advancement that can still go. But I agree with Dr. Songer is that this plastic translucent solution is very challenging from a particle filtration, from an environmental, but also from a safety, because that you're breathing in that toxic plastic, and I don't advise that.
Oh, Wendover, how has your team approached these accessibility considerations?
Yeah, it's interesting that the plastic transparent shield masks, my friend here in San Francisco, she's been a nurse at Cal Pacific Medical Center. She patented about 20 years ago a Clearview mask, which has a transparent, and it was mostly to prevent, to enhance communications in the surgical theater. So basically, she was adopted by, deaf nurses and physicians, and she's just brought the product out this year. In terms of head suspension, we definitely moved quickly to offer an alternate head suspension behind the head. But in terms of, the special needs, because of our manufacturing, setup, we're not really able to adjust like Sky has, make 5 copies of a different size, and we haven't addressed the hard of hearing issues at all.
All right, well, thank you. These are tricky challenges to address, because you're talking about smaller parts of the market and very particular challenges. So how these get approached, I understand is a challenge, but I appreciate all efforts in that zone. I have 2 more questions. My first question is, looking out this fall, what do you see in terms of the market? Do you see a diminishing market, or do you see that your market is still expanding?
Well, I'll go first. I'm very passionate about this. My cheeks are turning red. Can you see? No, okay. So I am not at all in agreement with the CDC relieving the mask mandate. I believe we're the only country where this has happened. I think it's very dangerous. I believe we're going to see a surge. We are already seeing a surge. And what I like to do is look at countries who have gone before us. I look at Israel. I look at the fact that they were the highest vaccinated, double vaccinated country. Now 50% of their cases are the Delta variant, including those who were double vaccinated. So I look at who's gone before us, and I study that. I said 80% of my job is textiles. Let me revise that. I would say 95% of my job is studying what is happening in other countries. The US tends to just think that we're the only one in existence, and no, we got to look at what's happening globally. I look at the World Health Organization for my data, for my science research and what's coming. So I do believe we're going to have another surge. I do believe it's important to prepare for that right now as mask makers, absolutely. And beyond the COVID pandemic, the way that we have hurt our planet, as we all know, these viruses are going to be a yearly event. Climate change is going to be a yearly event. We have building collapses now. We have airplanes malfunctioning in the middle of flight. We have to have a mask with us at all times to protect ourselves going forward. So don't listen to the hype as mask makers. Do not listen to political narratives and agendas. Don't listen to media outlets. Listen to your own intuition. Watch the science, the real science of what's going on around the world, and listen to actual bioscientists. So that's what I want to, I just think it's really critical for us to follow our intuition. We were guided, we were given this for a reason. It is needed. You are needed. You are important. Keep going. Please keep going and prepare for the fall.
Wendover, as you're looking out to this fall, what is your team looking at, and what do you see in terms of how the market will develop?
Yes, I think we have a strong market going forward, but there's been a lot of over manufacturing. So we've, for example, designated certain blocks of our inventory for donating Harlem Health Services, AME Church, Capuchin Soup Kitchens, vaccination centers, so that the masks can do some of the work of getting us to the other side. But we've been looking for the past year at what is the baseline of demand post-COVID, post-vaccine. And we know that there is a larger demand than before the pandemic, but compared year on year to 2019, but it's greatly reduced in an environment where masks are no longer mandated. So, but of course, all of us know that, we're not to the other side of this until every country and region has found peace. And so we're cautiously trying to manufacture at a level that will correspond to a changing demand.
Yep. All right, I have one last question. Jocelyn, if you want to speak to that, you're welcome to. Otherwise, I was just going to ask for, what are the upcoming obstacles and challenges in this world of reusable mask making that your teams individually see? So maybe Jocelyn, I'll start with you, and then we can go to Skye and finish with Wendover.
Right. So I think that there is going to be an ongoing demand for reusable masks. We already know that there's an increasing demand for masks for pollution and smoke and allergies as more and more people become aware of that need. So I think that the sustainability of that portion of the market is clear. For masks for infection control and pandemic relief, we're all still uncertain how much adoption we're going to see carry over from the populations that want to make sure every flu season or as the new rounds of COVID and everything else come through, that they are personally protected. So that market is still hard to assess. And one of the things that F-3502, the F-3502 standard may do is create an occupational setting and demand for for masks for people on frontline positions and all sorts of things that way. But we don't know how that's going to play out yet. We're still not seeing widespread adoption of this standard in industry or in occupational settings, although it's starting to trickle through. So the CDC and the FDA are now, like, if you search hard enough, you can see that they're starting to talk about this new standard, but everything's evolving. And so there is a lot of uncertainty there, but I think it's not whether there's going to be ongoing demand. I think there is. The question is how much, and how much innovation and market footprint we can sort of expand into.
Jocelyn, you and I have talked quite a bit about the idea of OSHA looking to implement this and seeing that as being a really good use of this standard. Maybe not for the medical staff, as Wendover pointed out, but for flight attendants and for people running a grocery store, and being implemented in that level of framework, it really seems to work well for that.
Yeah, so I think that question is twofold, and it starts to get into some of the things we were talking about earlier in terms of public education, because education on when and where the different mask types are useful is going to help drive demand for people wanting masks in those contexts. I can tell you, I think we mentioned before, I'm asthmatic. I used to find that every time I got home from a trip that involved an airplane, it was repeatable and predictable. 7 to 10 days later, I got sick. It was virtually guaranteed. And so as of 2016, I haven't gotten on a plane without a mask. And I have to tell you that for most of those years, my mask of choice was a Vogmask, because I started using Vogmasks, I think, in 2014. So long time fan and user. But
excellent.
I definitely use different masks for different tasks, and sort of growing the education will grow the demand and help fuel innovation. And I think we're all looking for that. And in occupational settings, in schools, in airplanes, for patients, for visiting hospitals, right? For people who aren't yet admitted. These are all places where the general public may start considering to wear masks. And like, from a personal perspective, I could go through and give you the list of all the places where I want to have my mask with me. And I've had masks with me, as I said, daily since 2016, and maybe even before that. And now I actually have an assortment. And I am one of the people, my sock drawer, like, I repurposed one of my sock drawers, and it's a mask drawer, and I have masks with all sorts of different filtration levels and breathability, depending on whether I want to go hiking, go to the grocery store, take somebody with me to the hospital, or empty the ashes from the fireplace or painting, right? You need different masks for different.
We have a mask drawer. We have a mask drawer in the entryway.
Yeah.
Right.
I've gone to the same thing.
Kind of like a sock drawer we repurposed. It's that kind of idea.
And a lot of the environmental concerns that are fueling the need for reusable masks are just getting worse and worse, and are requiring us to need more and more masks. So it's some interesting feedback.
Jocelyn, if I can give Skye a minute to close, and Wendover just a few minutes at the end. I want to make sure we get to the end here, because everybody has been very patient going through this detailed talk with us. So Skye, what are some of the obstacles and challenges you can see going forward for the real use of masks?
Yeah, I think the biggest challenge are these mask off people. They just, I've gotten videos of people burning my mask. I mean, I just go, everybody's going to have different viewpoints. My family is on Twitter, #MaskOn. Those are my peeps, people that just see the common sense of it all. Those who don't, I'm not trying to convert you, I'll let you have your beliefs. But if you look at science and you're kind of a science nerd and you just look at the science of masks, it just makes sense. I'm sorry, it just makes sense. So I go to #MaskOn. I find my people. When I start to get down about this whole thing, or I think, oh, what am I doing getting into this business? I'm crazy, forget it, let me shut my doors. I just remember, I go to that tribe of people and I remember all the people that do love masks and do value and appreciate us tremendously. I think about my mom, who breathes better with my mask than without. So, you know, I think about those people. I go back and read all the testimonials we've received, and I just keep going, you know, I just keep going no matter what, because there is a need. Everybody gets colds and flus all year round. And for that reason alone, I don't know about you, but I hate being sick. I can't stand it. So yes, if I'm going to prevent that by wearing a mask in the grocery store, I'm gonna wear a mask in the grocery store. You better believe I am. Whoopi Goldberg, okay, we all know who Whoopi Goldberg is. She is never going to be without a mask in her purse for the rest of her days. And she says that every single time on The Voice, she reminds people of that. It's just, you know, there's a huge tribe of buyers out there. There's a huge tribe of supporters. And I just encourage everyone to tap into those people. Let them feed you, let them recharge your batteries, keep going. You're providing a service to humanity, no matter what the haters say, the mask offers say. So there you have it. That's my put a into
Stamp
it.
on it. Yeah. Wendover, will you close us out here?
Yes, sure. There are always going to be challenges. I think every product can be made better. And all of us need to be involved in protecting global public health, especially in the face of climate change. So we have to work together. We have to have these panels. We have to share information. We need to, be inspired by each other, as Skye says. And those are the challenges going forward. Paying attention to our planet is probably the highest mandate. If your mask can speak to that concern, then we're all making a contribution.
Excellent.
Thank you so much. I cannot thank all three of you enough for coming and talking this through. You guys have really, stood up to a challenge that COVID has really thrown our way, and you've really made a difference, and it's really appreciated, all the hard work you've done. I'll drop into chat a link to each of their websites, so anybody who wants to take a look at them, they're welcome to take a look. And Barry, I will hand it back to you to close us out.
Thank you so much. And I just wanted to say, Dr. Songer, thank you very much. James, Skye, Wendover, Angie, Shabnam, I want to thank everybody, all of the panelists, the team at Helpful, the teams at Helpful, and the teams at Maker Mask, and the other groups that helped put this whole thing together. Brianna, James, Jose and Angie, everybody who participated and pull this together behind the scenes. I want to thank you all. This has been an amazing couple of hours here. I certainly learned a lot about something that, I felt pretty okay about, but this really rounded out a lot of knowledge. And this, please, people, click the links before you disappear from Zoom, before we turn off the whole thing, and make sure that you visit these sites. Thank you all very much. It was wonderful being with you all.
Thank you.
Thank you.
Bye now.
Thank you.
Thank you. Very nice to be here.
Keep going.